Right, so Cassidy, you sent me some questions here. We'll look at the questions and I'll explain the concept. From this list here, what are the trouble ones? What are the troubling ones? Let me hear.
Alpha
Anybody?
and beta.
Alpha and
Alpha and beta, um, coordinate geometry.
all right. What else? What else is a cause for sore eyes? Anybody?
Inequalities, like just knowing the order sometimes.
Yeah.
Okay, no problem. Well, there we go. So that's enough for these type of questions. So Cassidy, you there?
Yes, sir.
Oh, come on, I see you, Cassidy. Normally this eye camera on
No.
all the time.
Yeah. Just now. You know, I'm warming up, you know.
Okay. Nathaniel,
Yeah.
Sheena, Caleb, I look upon the camera and thing, it's vibes. I mean, it's just like a few of us. Need to be scared
So I
about.
didn't come prepared for that. I didn't come
This
prepared for
is
that at all.
Oleo. Right now, I know about some shit. I'm like, hey, if I could put my camera on the
your
camera.
shit's holy. Your shit's
Yeah,
holy. No,
my shit's are boss up Poland. Hey, I probably shouldn't be showing like this. I go think I'm homeless.
Nah. Don't worry.
All right, so let me get into it. Cassidy, first things
Yes,
first.
sir.
When you are integrating something in the form ax plus b to the power n dx, okay, when you're differentiating, right, and you see something like this, we just use to differentiate.
Chain rule.
You just use the chain rule, right? Now we know that
Yeah.
integration is a reverse process of
Differentiation.
cool, very good. So let me show you something, right? Consider you had a function y is equal to 5x plus 7 to the power 3, right? I want you to differentiate this for me. Differentiate that for me. Using the shorthand
Nah.
version of the chain.
So I fear my add math skills just not this good.
All right. So when you're using the shorthand version of the chain rule, you're gonna pre-multiply by the power. So what's the power over there? What's the power?
3.
3. So I'll say 3 in front. Then I'm going to differentiate the inside. What's on the inside?
5x plus 7.
If I differentiate 5x plus 7, what would I end up with?
5.
5, correct?
5.
5. And all you're gonna do now, you're gonna write back what was inside the brackets, and with differentiation, what do you do with the power? What do you do with the power?
Subtract 1.
Right? So this would now be to the power what?
2.
2. Good. And that's it. 3 by 5 is 15. 15 by 5x plus 7 squared. Now that is differentiation. Now, if we were to integrate this, what are we supposed to get back? If I integrate dy dx,
5x plus 7 to the power 3.
so here how I want you to think. So when I was differentiating, I multiplied everything by 3. Then I multiplied by the derivative of whatever was inside the brackets. And then I minus 1 from the power. So let's think in reverse now. Let's try to think in reverse. So I'm going to integrate 15 5x plus 7 power 2 dx. So let's think in reverse, Cassidy. So when we were differentiating this, what was the first step? What's the first thing I did?
Wait. You multiply
Multiply by?
the power.
Right. So if you do the opposite, what do you think your first step would be?
Divide by the power.
But here's the thing. Right? The power was originally what? What was the power originally?
3.
3. So you're not just going to multiply by the power. Here's what you're going to do. The first thing you'd have to do is add back 1 to the power. And if you add back 1 to the power, that'll be what?
3.
3. Okay, cool. So I'll put 3 here. And then, like you just said, I multiplied by 3. So what will I do now to reverse the process?
Divide by 3.
And what else did I multiply by on the outside?
5.
5. So I'm going to divide by what as well?
5.
Right. And that 5 going to go in the denominator. So you end up with 3 by 5 in the denominator. And let me show you the magic. Don't forget plus C is indefinite integration. Check this out. Check this out. What's 3 by 5?
15.
What happened there?
15s would cancel.
To give you back the original thing,
And
yeah?
then you get back. Yeah.
Right. So anytime I forget how to do this in the exam, all I do is I look at an example with chain rule and I just reverse it. Because integration is just a reverse process. So let's run through these steps again there, Cassidy. Anytime you see something in this form, ax plus b, something in brackets to our power, your first step, you're gonna do what to the power? What was the first step I did here? What was the first thing I did?
You add 1 to the power.
Good, I add 1 to the power, then I do what?
You divide by your power.
Multiplied by
50. Well, 5.
5. You think you understand the reverse process of the chain rule?
Yeah.
So stay with me. Stay with me.
Same.
So let's generalize that. Let's generalize that. So we're gonna generalize it by applying it to this form. So you tell me the steps. What's the first thing I'm gonna do with this? You tell me. I'm listening to you.
Okay. So you'll have we integrating. Okay.
Yeah.
So we add 1 to the power, so you'll have n plus 1.
Right, so I'll write back ex plus b.
X plus b, and then n plus 1 dx.
You're going good so far.
And then you're gonna put that over n plus 1 by a.
Yep, that's it. That's it. Plus c.
Yeah.
Isn't that the exact same thing we did over here? Just an example.
Yeah.
Yeah, it is. So let's look at it one more time. If you see something like this, you have to do the opposite of the chain rule. So you add 1 to the power first. That's your first step. So this 2 turn to 3. Then, instead of multiplying by the power, you divide by the power. So I said divided by 3. And you also need to divide by the derivative inside the bracket. If you differentiate the bracket, that's just 5. So I said 3 by 5 in the denominator. And that will give me back the original answer. So you add 1 to the power and you divide by the power multiplied by the coefficient of x. That's all. You're sure you understand or you're confused?
No, I understand. I understand.
What if I told you that's what I had to do here? You go believe me?
Yeah, because squaring it is just, well, the root of it, if I do the opposite, will be to the power of 2.
Wait, take your time. Take your time. So we use this rule anytime you have a binomial term raised to a power. So what does the square root mean? What does square root mean?
Raised to the power of 2.
Nah, not to the power 2.
To the power of a half?
Right, to the power half.
I knew that. I knew that.
So I'll put 2x plus 1 in brackets and raise it to what power?
A half.
Half. So let me ask you a question. Did I integrate us yet? Yes or no?
No, sir.
Anybody else? Sheena? I'm not sure if you did integration as yet. Did any of you all do integration yet other than Cassidy and Virginia?
Of course not, sir.
No.
So we barely like make it through integration. I should probably say that.
Okay, I see. Well, this is just a reverse of differentiation, and I guess a good bit of you all did not do differentiation as yet. So some of you all kind of
Very
lost.
true. Very.
Virginia and
We
Cassidy,
do
will
it.
This school
Yeah,
Sweden?
we do differentiation.
Well, we didn't do integration yet, but I remember when I was with you on the live. So
Okay, cool, cool,
yeah.
cool. So here what? I did not integrate as yet. All I did, I just rewrote this in this form. Guys, what does square root mean? Come on, what does square root mean? Square root, what I mean?
3 power of
To the power of a half. So all I did was, instead of writing the square root of 2x plus 1, I wrote 2x plus 1 to the power of a half. So Cassidy, you understand I didn't differentiate yet. What's it? I didn't integrate yet. I didn't integrate
Yeah.
yet. Why do you think I'm putting it in this explicit form?
So that we'll be able to do chain root,
Well, reverse chain rule.
but like the opposite of chain root.
Good. So let's do it now. You tell me what I should do.
Okay, so boom. You're gonna write back 2x plus 1. And
You go
then
with
you're gonna add 1 to the power. So you'll end up with 3 over 2. You're gonna put that over, well, 3 over 2 multiplied by 2.
That's it, you know. That's literally it. That's literally it. Don't forget the
Plus
plus c.
Yeah.
So that's 2x plus 1 to the power 3 over 2. What's 3 over 2 by 2? 3 over
3.
2 by 2. That would be 3 plus c. Cool. Now, if you want to take this a step further, this is fine. But of course, if you want to take it a step further, Cassidy, are you okay with indices?
Yeah.
Yeah? Okay.
Hopefully.
Did you understand everything I did so far?
Yes, sir.
All right, cool. Here's what we're gonna do next. 3 over 2 is the same thing as what by what? Could any of you all think of a product that would give me 3 over 2? Think, Cassidy. Is there any product that would give you 3 over 2? Think.
I think.
So we're looking for two numbers that would give me back 3 over 2.
0.5 and 3.
Right? So a half and 3. Half and 3 would work. Probably saying, what I mean? Well, I'll show you. So Cassidy, I could actually say 2x plus 1 to the power of 3, and I could raise that entire thing to what power to get back 3 over 2? What power would I raise that to get back 3 over 2?
Uh-huh.
A half, yeah. Yeah.
Mm.
That's, of course, that's over 3 plus c. Now you'll see where I'm going with this, I promise.
I'll see.
So, over here, you see now you have 2x plus 1 to the power 3, but that entire thing is being raised to what power? What's the entire thing being raised to?
Uh-huh.
A half. And raising something to the power half literally means what? What does it mean?
Square root.
It means square roots. So I could rewrite this as what? Let me see if you could figure it out.
2x plus 1 to the power 3 roots over 3.
Nah. So, question, if I had x to the power half, what would that mean? If I had x to the power half, what would that mean?
Root of x.
That would mean the square root of x, right? If I had y to the power half, what would that mean?
Square root of y.
Alright, if I had y by x to the power half, what would that mean?
The square root of y by x.
Good. If I had y to the power b to the power half, what would that mean?
Y to the power of b. Well, the roots of y to the power of b.
Alright, the root of y to the power b. So tell me, what do you think this would be? Same concept.
The root of 2x plus 1 to the power of 3.
Yep. That is it. That's the most complete answer. But this is acceptable, right? This is acceptable. This should just be an extra. Well, no, all the girls like to be extra, right? So
Oh,
extra
yeah.
limits anyways. So that's it, Cassidy. Let me know if you're okay.
Yes, sir. This was great. I learned something.
You sure it was good?
Yeah.
Now you know this is not the hardest way they could bring it, right? So let me put you all in some deeper trouble. Let me give you all a question. I want you all to integrate 3 square roots of 1 minus 9x. And I'm giving you all 2 minutes. Cool. So Kamaya, Nathaniel, Sheena, you all didn't do integration as yet, but I think you all could get through with this. So let's go through the example I did here. So Kamaya, did you know that square root means something to the power of a half or not?
Yes, sir.
All right. So when you look at this question, what's inside the square root?
2x plus 1.
That means 2x plus 1 is being raised to what power?
A half.
Good. So do you understand that from here to here, I just wrote it in a different manner? I didn't do anything yet. I just wrote it in a different way. That's all.
Yes, sir.
Okay? Shayna, talk to me. Shayna, talk to me. I don't know if you're alive. I don't know if you're okay.
Yeah. I like.
Right. So Shayna, from here to here, all I did, I just changed the square root what to what? What does square root mean, Shayna? You don't know this for indices, eh? You don't know this. What does square root mean? Yeah, I'm not hearing Shayna. Nathaniel, you want to tell me what square root means?
What square root means? It means
Okay, instead
I
of
don't know how to define it.
what's another way of writing the square roots? Instead of writing this, what's another way of meaning the same thing?
Well, to the power of a half.
Yeah, that's it. To the power of a half. That's it. Now the reason why I wrote it in this form is so that I could have utilized this rule. So Nathaniel, can you see that we have a binomial there, raised to our power? You have 2x plus 1 to the power of a half.
Yeah.
Can you look at this and compare it to this and see it looking like almost exactly like that?
Yes, I can.
What do you think A is if you were to compare?
A would be 2.
What do you think B would be?
B would be 1.
And N would be what, Kamaya? Kamaya, what would N be?
A half.
N would be a half. So here's what, Kamaya. To integrate this, you are going to add 1 to the power. That's your first step. So Kamaya, what did I do to the half? What did I do to the half?
Yeah, I added 1.
I add 1, so that's a half plus 1. Cool. So I added 1 to the half. Now what's a half plus 1?
Um, 3 over 2.
3 over 2. Good. So that's why in the next line, you'll see I have 3 over 2 instead. Now, if we're utilizing this, in the denominator, it says n plus 1 by e. Now, of course, n plus 1 is a new power. So, Kamaya.
So,
Yeah, Kamaya, talk to me.
why we added 1?
Okay. The reason we add in 1 is because we're reversing a chain rule. And when
I
you...
didn't want to chain rule in.
Okay, for now, just accept it. But when we're
Alright, no problem, no problem.
when we're going further into differentiation and you understand the chain rule, you'll see that what I'm doing here is just reversing the chain rule. When you're differentiating, you typically take away 1 from the power. So when you're integrating, you have to reverse the process. So you know what you're going to do? Instead of minusing 1 from the power, what you do?
Plus 1.
So that again?
Plus 1.
Exactly, plus 1. So that's why in a nutshell, are adding 1 to a half because are integrating, which is the reverse process of differentiating. So, in the denominator, you have n plus 1. N plus 1 in this case would be 3 over 2. And if you're comparing this and this, what would A be?
2.
A would be 2. So I said 3 over 2 by 2. From there, I mean, you could just simplify it and write this answer and you're fine. Of course, if you want to be extra, you could give this answer, but this is fine. That's fine.
Okay, sir.
That's the whole process. Virginia, did you send me an answer?
Yes, sir.
Sir, almost done.
Okay.
Okay.
Alright, so I'm gonna run through the work in here. So Cassidy is gonna help me with this one. So Cassidy, what is the first step?
Well, since we have, this is basically 1 minus 9x to the power of 3.
Nah, not to the power of 2. This 3 over here is not cube root. That means we have 3 multiplied by the square root of 1 minus 9x. Yeah.
Oh, that's wonderful. So it would be 3 multiplied by brackets 1 minus 9 to the power of a half.
Did we integrate it yet?
No,
No.
we just put it in a different form.
Correct. Now, I know you're familiar with the form ax plus b to the power of n in this specific order. So when students see this, their brains might go into array. This array, they're gonna be like, what? They're looking a bit different. Cassidy, even though it looks different, is it not the same form?
Yes, sir.
Question. I want Cassidy and Virginia to stay quiet. Potentially Sheena. But guys, here what I'm saying, right? If you're comparing this form and this form, what do you think A would be? Let me see if I have this locked in. What do you think A
9.
would be?
Minus 9.
Minus 9.
Good. Pick up all yourself. A will be minus 9 because A is the coefficient of x. What do you think B would be?
1.
1.
And what do you think N would be?
A half.
Yeah.
Good. Now you see this little tree on the inside? Pay it no heed. If you want, and you want to make your life simpler, 3 is being multiplied by the function that you're trying to integrate. So you could actually take that 3 and you could put it on the outside like so. So in the next line, you could actually just say 3 integral 1 minus 9x to the power of a half dx. And Cassidy, now we could integrate this like normal. So tell me what's the next step from here, Cassidy?
Okay, so I'm gonna add 1 to my power, so it would be a half plus 1, so to the power of 3 over 2.
I said I'll turn the 3 over 2. Good.
And then it's gonna be over my power 3 over 2, and then 9 multiplied by 9.
Take your time. Guys, do you think, okay, what is the coefficient of x? Is it positive 9 or negative 9?
Minus 9, negative 9.
Negative 9.
Cassidy, if you make a little mistake like that, depending on how mean your teacher is,
Yeah,
it might
yeah,
get it kind of wrong. So, I don't want to let you make mistakes like that. The coefficient of x is actually minus 9. So, cool. Let's simplify now. And anytime you integrate without bounds, that's indefinite integration. And so you have to add on plus c to cater for any constants loss. So how are we gonna simplify this, Cassidy?
So we'll say 3 over 2 by 9 by minus 9. And you'll get minus 27 over 2.
Let me show you something, right? If I was in other shoes, check what I would do. Until everybody have a calculator. You don't even have a Casio. The point is
Yeah.
until everybody have a calculator, right? Cool. What I would do in my calculator, wait, give me a second. I would put 3 on top. Basically, I put in all the constants into the calculator. So I had a 3 on top, I put the 3 on top. In denominator, I'm going to open a bracket, press the fraction button. What do you think I'm going to put there for the fraction? What do you think I'm going to put there?
The denominator. Same.
What am I going to put there? So I put the 3. What next?
3 over 2 minus 9.
3 over 2. And just like that, I get the final result, which is minus 2 over 9. Cassidy, let me know if you understand how I did that.
Yes, sir.
So all I did, obviously the calculator can't work out any of this, and you can't simplify that. However, you could simplify the constants. I have 3 multiplied by something divided by 3 over 2 by minus 9. So you see all of this, I could actually put that directly into my calculator. And you're going to get minus 2 over 9. So you're going to end up with minus 2 over 9 by 1 minus 9x to the power 3 over 2 plus c. How are you feeling about that? Good, bad?
Great.
Good. I thought the 3 wasn't a constant. I thought it meant root 3. Wow.
Oh,
Yeah, me
same
too.
thing on custody. That's,
Me too.
yeah. Kamaya, if I have anything you want to just run through back again, talk to me. I will do so. Nathaniel, Caleb, Shayna, talk to me, guys.
No, sir.
No, sir.
Yeah, sir.
Before we move on, I want to give you all one more question like this, just make it even a bit harder for you guys. How fun, right, Cassidy? How fun.
Wow. Wow. I feel like I'm gonna be like this when I become a chemistry teacher.
Like
Every
what?
question just up the level of difficulty, you know?
That what you had to do. That what you had to
But
do.
here's the thing with chem. Chem isn't hard.
It
It's
is.
just, you know.
I feel like
It
I
is.
think you might have to join Chem Vibes.
I will join Chem Vibes. I will learn some chemistry, but I think the problem with chemistry is that it's such an abstract topic. With maths, you can kind of put sense into it. With chemistry, it's very niche.
Chemistry is probably the most sensible subject it has out there.
I would
That's
Cassidy,
the
that's
biggest
just
lie
not
I've
true.
ever heard in my life. What
No,
is that
Cassidy, that's
thing,
just
bro?
not
Like,
true.
Earlier.
What is that thing?
Like, Ole, no. Cassidy, respectfully, I feel like that's a lie. In maths, let me show you how common. Look, I wouldn't say, common sense is not a nice word to use. Let me show you how logical it is. Stationary point. Imagine you throw a ball in the sky, right? At what point in your journey do you think the ball was a little stationary? For like a split second. If you had to say,
it's
where do you think the ball would have been stationary?
maximum point, you know?
Over here, right? Because like over here, the ball going up, going up. Might stay there for a little bit, and then they're gonna come down. Stationary point. You see, like this kind of intuitive, right? Chemistry? What? If I see something like C6H12, what I mean?
That's common sense too. Like,
No,
come
I
on.
wouldn't say that.
No, I believe, guys, if you learn the periodic table, chemistry is not hard.
Don't worry,
All
come
of you
on.
will better be present at Chem Vibe.
Yeah. Don't stick. Cassidy go handle all you, right? She go handle all you.
Guys,
So-
I just glad my teacher think that. So, when I get in thoughts,
You're
everything,
gonna have
what
fun.
she talking
You're gonna
about.
have fun. Yeah.
It's nice to be taught by somebody who's passionate about what they're doing. That's the most
Someone
important
asked
thing.
me, someone asked me today why I like chemistry, and I believe the love for chemistry comes from being absolutely fast and inquisitive about how things are made and how things work. So
Well,
just adopt that mindset, guys. You just have to know about everything.
that's a very good mindset, and it's definitely carried me throughout my science journey. That's exactly how I think as well. But chemistry it's just I appreciate it as a science, as an art form, like knowing how things work, but it's just my chemistry teacher made it so that I didn't like it. Maybe if I
I
had Cassidy as my teacher, right? If Cassidy was real,
Yeah.
like much older and she was a teacher, maybe.
So why you was recommending me to your teacher if she made it hard?
Oh no, that's okay. Let me explain this. In my school, there were two different chem teachers, right? The one I gave you, amazing teacher. She's the reason I get my ones and distinctions in chemistry. In secondary school, like Form 5 and in upper and lower 6. She's an angel, right? She's an angel. Then there's this other one who was a school teacher for chem. That wasn't a fun time. That wasn't a fun.
Okay, so
And
makes sense.
the teacher sent you the number for. She actually gave us free lessons. Like, because at one point we were her class, and she just continued just giving us free lessons. That woman is an angel. Yeah.
Alright, so alright.
But anyways, a little time starts now. Give that question a try. I believe you all could do it. I don't think is something you can't do. If you have trouble with indices, though, it'll give you trouble.
So, you want to go over some indices for the evening or what? Like I don't have trouble, I just have a test coming up and in lessons revising it would just be,
That's a
just
problem. I mean, that's why I'm here, right? Once I'm willing to learn, I here. Are you willing to learn?
unlogs. Unlogs.
Come on,
Unlocked.
you're willing to learn.
Foods.
Of course, sir.
Good. Are you all getting through the question? That's not fifth fruit, eh?
So,
Don't get any funny ideas. That's not the fifth
yeah,
fruit.
yeah. Right.
When Virginia's thinking, like she scratched her beard. Like, cool, so
Oh my god.
I think that's why I took off the camera. I was like, you're like in deep thought.
Nah.
It's my pencil ran out of lead. This is a crisis.
I want if only Nikolai was here and you see that statement, you know?
Yeah.
So I have a question.
Yeah.
When you're multiplying by the constant at the end, do you just multiply the numerator? Or no?
You multiply the numerator.
Or is it just like the whole fraction?
Wait, so you talking about like this?
Yeah, when you're multiplying the 3 by that. It was the whole thing.
It's 3 over here?
Yeah.
Yeah, so if you wanted to do this a long way, you would multiply 3 here by the -9, and that'll be -27. What's that? That'll be -27 over 2. And of course that was divided by 3. Yeah.
Oh, okay, I see.
And then that would work out to be 3 multiplied by 2 over -27. 3 into 3 is 1, 3 into 27 is 9. You're gonna end up with -2 over 9.
Oh, okay. Thank you, sir.
No problem. Okay, so the time is up. Did anybody get through?
Almost.
Yeah. Almost there.
Oh, later, let's think I can still back.
Anytime.
Yeah.
I'm here.
I'm here.
Labor Day. Are they doing labor? Are they doing mental labor?
Oh, yeah. I messaged Sis. I asked her if we have lessons today because, it's a holiday and, we're going to sleep. But we here. because the grind never stops.
Grind don't stop.
Yes.
Okay, I can answer the question now. So, similar to the first question, well, not really the first question, but similar to this question, are you all seeing any constants that we could pull out potentially? Kamaya, are you seeing any constants we could potentially? I see Shayna on mute. I'll give it to Shayna. Shayna, are you seeing any constants we could potentially pull out?
Five.
We could pull out the 5. Question, Shayna, why can't we pull out the -1? Do you know why we can't pull out the -1? Any?
I wouldn't put it -1, but I don't have a logical answer to give you. But I didn't pull out the minus.
The question is the -1 minus 7x. What is that in? Like, okay, what is that in? That's in the what? What is that in?
I forgot the name, but the Latin.
Square root?
Well, yeah, but
It's in the square root.
okay.
Say that again, Shayna.
No, I wasn't saying anything.
Oh, yeah, it's in the square root, so you can't pull it out, right? However, is the 5 in a square root or anything, or is it just there hanging around?
There.
It's just there, right? So I could pull out the 5. That might make my life a bit simpler.
So I don't really know why we pulling out. I don't really know what's going on. Low key.
Okay,
Why Cassidy laughing?
No, because I like her honesty.
yeah, I like Kamaya's honesty as well.
I hope you're dishonest during chemistry.
We'll see about that.
So, Kamaya, you could think of this like, okay, let me go back to SCA. Say we had 5/10, right? You had 5/10. And I could say that's just 5 by 1/10 or not?
Yes, sir.
I could do that, you sure? Yeah? You okay with that?
Mhm.
So
Yeah.
this function over here could be written as what? What can I write this function as? Using that same concept.
5/1 multiplied by root -1 minus 7x over 1. Oh, yeah.
Right. Now, this part over here, are there any variables in that part?
No, sir.
No, so when I integrate, it'll just be 5 times what I integrated. If you understand what I mean. Okay, look at this part over here. If you realize we're multiplying this function here by 5. Look at it. 5/1 is 5, and you're multiplying this function here by 5. Why am I calling it a function? I'm calling it a function because are you seeing any variables over here?
Yes, sir.
Right. Are you seeing any variables over here?
No, sir.
No. So what we're doing is we're integrating a function, but we're not just integrating a function. We're integrating a function times what? The function is being multiplied by what?
Um,
So this is the function here. The function is what has a variable in it. This is the function. And the
mhm.
function is being multiplied by what?
A constant.
Exactly. So you could pull out that constant because what you really care about is the function. You're integrating the function. When you integrate a constant of multiplication, nothing's going to change. So you're really integrating the function. And when you integrate the function, you'll multiply by 5 again. Because it's 5 by
So,
the function. It's 5 by the function. Say that again.
you're saying integrate, and I know you say it's just the opposite, deriving, but like, I
Differentiation.
don't know what yeah.
I feel like you gotta.
Yeah, I think I need a whole class on the basics.
Yeah.
Yeah.
But the point is, I could rewrite this as 5 multiplied by a function. So if that's the case, I could pull out the 5 because the 5 is just a constant. I could pull that out, and on the inside, I'll be left with the raw function by itself. So I'll be left with 1 over the square root of -1 minus 7x dx. Now,
Oh,
is
so
it?
like it's in the form that you gave us before, like kind of.
Yeah. Yep. So
Okay.
you'd be able to put it in that form. Now, we have 1 over the square root. Now, here what? Remind me, what does square root mean? So what power? What does that mean?
A half.
A half. So I could rewrite this as 1 over what?
-1 minus 7x. Well, yeah, bracket to the power of a half.
But this is not quite in the form I want. I want it to be in. I want it to be in the form ax plus b in brackets to the power of n. Are you guys seeing any fractions over here? Yes or no?
No, sir.
No, sir.
No. So let me take some suggestions. I want to put it in that form. So what do you think I should do here?
Make the half negative.
Right. I'll take the denominator and I'll move it to the top. And if you move something to a power to a different location, what happens to the sign for the power?
Becomes negative.
It will change, right? So on top, you're gonna have 1 multiplied, but I don't have to put 1, right? Because, okay, you have 1 here, but, okay, do I need to put the 1 back? Like, if I have 5 by 1, what's 5 by 1? What's 5 by 1?
5.
5, so I really don't need to put the 1 back, right? When I bring this to the top, it'll be 1 by that entire thing, but I don't need to put the 1, because 1 by anything is anything, right? I'll give you back the original thing. So I'm just gonna write -1 minus 7x, and I'm gonna raise that to what power? Tell me, come on now.
Minus a half.
Is it in a form now where I could integrate it that we know how to deal with?
Yes, sir.
It is. So come on, I run me through these steps.
You have to plus 1 to minus a half.
Right? Now we're gonna answer this 5. When you tell me that, what happened to that 5 there?
You have. I don't really know what has happened, but I know the sign does go away.
Wait.
The integral sign does go away.
Right, the integral sign is go away because now you're actually starting to integrate. This whole process I did here, I didn't integrate yet, I just trying to put it in a form I could integrate. So here's what. Yes, do you understand that the function is what we actually want to integrate? We actually want to integrate the function. So I pull out the 5, so this is actually the function we're trying to integrate. Now, the integral of that is just going to be multiplied by 5, because 5 is just a scalar multiple. So this 5 is just here chilling, and when we finish integrate, I'll just multiply the integral by what? I'll just multiply the integral by what?
5.
5, right. So I'm going to put back the 5 here, because 5 is just a scalar multiple, right? It's just a scalar multiple of the function. So we're going to integrate the function, and after, don't forget, we have to multiply it by 5, because that was the scalar multiple. Let's do the integration business like normal. Tell me what to do.
Bracket -1 minus 7x bracket 1 bracket, well, to the power of negative a half plus 1.
And again, in your case, you didn't do differentiation or integration yet, so I understand how a lot of things don't make sense. Like you probably might want to ask,
Yeah.
where you get our plus C from?
I don't even know where you get the dx from, but I understand that it has to be there because that is the formula or something.
The dx is there. Okay, integration is actually finding an infinite sum below a curve, and dx is like a very very small change in x, and the integral actually means sum. Like, okay, I agree, when we do an integration, you go understand, but like, just think of it like this as now. What's the variable in this function? Look at our function. What's the variable?
X.
Right. So I want you to think of it like this for now. You're integrating the function here with respect to, you can think of this as with respect to x, right? You're going to integrate the function with respect to x as a variable. That's a variable in the function. Take, for instance, if instead of minus 7x, you had minus 7y, what would I write here? I'd say what?
The y.
I would say the y because I would have a function now in terms of the variable y. So I would integrate that with respect to y.
So when we eat integration, what we finding?
Okay, let me show you.
Sum.
Let me show you. Check this out. Check this real fast. People that understand integration already, check this out. They might be mind blown. Let me just say we had a function here, right? And this isn't even a function. Let me just say that that would be, let's just say y is equal to 7, right? Yeah. Let me just say that there's a vertical, or saying a horizontal line passing through 7 on the y-axis. And let's just say I want you to integrate that between, somebody give my value for x here.
2,
And give my value for x here.
4,
Right. When you integrate y is equal to 7 between 2 and 4, what you are actually doing is you're actually finding the area bounded by the x, by the lines and the graph. So what you're actually finding for is this over here. And if you don't believe me, I can show you a little proof. Right? Come on. What is this dimension over here? Between 2 and 4, where's that dimension?
2.
And what's this dimension over here? This is 0 here, it's a 7. So
5? No. Oh, that's 7. Yeah.
and what would the area bounded by the x is equal to 2, x is equal to 4, and y is equal to 7 be then? What would this area be?
7 by 2.
Right. Which is 14. Now, Cassidy and Virginia, look at this, right? Cassidy, you learn how to do find area on the graph already? Okay, well check this. Check this for a moment, right? When I'm integrating, I'm going to look at the upper and lower boundary, or the upper and lower limits. That I want you to think of that as what bounds the area. So Cassidy, obviously you have this line here, but what else bounds the area? The area is bounded by what two lines?
2 and 4.
2 and 4, right?
Yeah.
So I'm gonna put 2 here and I'm gonna put 4 here. And then I'm gonna integrate y. Y is equal to 7. So I'm gonna integrate that with respect to x. Let's just say this is the y-axis and this is the x-axis. Now, Cassidy, if I integrate 7, what would I get? What would I get?
I don't know.
Okay. If I integrate 7, I would actually get 7x.
Okay.
Because I'm going to show you something, right? Cassidy, imagine you had y is equal to 5x, right? Wait, no?
Yeah.
If I differentiate this, what would I get?
Y is equal to 5.
Okay. And so if I wanted to undo the differentiation, I would do what?
Well, put back the x.
Right. And that process is called integration.
Mm,
Because like I'm gonna preach today, integration is the reverse process of
differentiation. Wait,
right.
so I have a question.
Yeah.
You know how differentiation is like finding the gradient at a point?
hmm
If we're doing the opposite of finding the gradient at a point, what would we call integration? Like,
Integration is used to find the original function using the gradient function. That's the purpose of integration.
oh, okay. Thank you.
And it's also used to find the finite area under a graph, as you'll see just now. Right, but anyways, Cassidy, if I integrate 5, what I'll get?
5x.
Right, because like I said, integration is just undo differentiation. Yeah? So if I
Yeah.
integrate 7, what I'll get?
7x.
Cool. So now all we have to do is plug in the 4 here. Plug in the 2 here. And we're gonna see some magic happen. What's 7 by 4?
28.
What is 7 by 2?
14.
What is 28 minus 14?
14.
Now that 14 has significance. What did that 14 stand for again? What's that 14? Come on. What's that 14?
Yeah.
The area under the graph y is equal to 7 bounded by x is equal to 2 and x is equal to 4. So when you
So
integrate, when you integrate, you're actually finding the area between the graph and some limits. And this process is actually called definite integration. Yeah, that's what integrations really do. That's the main purpose of integration. Yeah.
Okay, so just one more question. The symbol itself is to show the distance between the two numbers.
Say that again?
The symbol, the integration symbol, is showing the distance between the two numbers.
You could think of it like that, but what it really is, it's the change in x. Let me explain. Cassidy, Virginia, like people, if all you catch on, if you all you catch these things, you'll be like legendary. So Cassidy, we're integrating 7 with respect to what?
X.
Right. So Cassidy, could you tell me what dx means?
Here's an X.
The change in x. This is going to blow all your minds. We started from x is equal to 2 and we went to where?
X is equal to 4.
Right. What was the change in x?
2.
The change in x was 2. So if I multiply 7 by 2, what would I get?
14.
Yeah.
Oh,
So
I have
now,
been blown.
Kamaya, you see how I just did that, right? Like when you integrate, stay with me, right, Kamaya? When you integrate, you're finding the sum of a bunch of infinitely small lines that would give you the area under the graph. That's what it really does. But anyways, so like this over here, this just means like a sum, right? It's just summing the change in x from 2 to 4. And Kamaya, let me show you something, right? Kamaya, look at this for yourself. dx means change in x. Kamaya, and this is the x-axis.
Yes, sir.
What is the change in x? If you start from 2 and you went to 4, what was the change in x?
2.
And what's the function? Well, I can't really call it a function, but what's the graph?
Y is equal to 7.
Right. So when I integrate from 2 to 4 for 7 with respect to x, what I'm really doing is I'm finding the area. You know why? Because this literally means 7 multiplied by the change in x. What's the change in x?
2.
What is 7 by 2?
14.
Yeah. So that's the significance of integration.
Okay.
So that's basically a hack to like do it fast.
It depends on what kind of function you get, right? Obviously, this was an easy function.
Okay.
This was an easy function. Y is equal to 7. And obviously, not all shapes will be like uniform like this. So let me give you an example. Let's just say you had a situation where you had a graph like this, right? And you had x is equal to something. I'll just say x is equal to 4. And then you had x is equal to 7, right? I want you all to tell me, do you think you'll be able to do that same trick as easily over here?
Nope.
Yeah.
No, you wouldn't be able to do that. You'd be able to find the change in x really fast. This change in x is 3. But if you realize you have like check this, right? I think listen what I see. What's changing? What property there is changing?
Why?
The shape?
The
The
height.
height.
The y
Height.
value is changing. The y value is changing. That's what's changing.
But I now say that.
You're correct. You're correct. Yeah, that's what's
Okay.
changing. That's what's changing. So when you integrate, girls, listen, and guys, when you integrate, this is what you're actually doing, huh? So Virginia, over here,
Yes, sir.
we're considering like integration real magical, right? But the concept is you're considering like a really, really small dx, a change in x. That will give you this dimension over here. And of course, if you want to find the height, I would take this value for x and I'd plug it in. And that would give my y value. Then I could use that to find out a really small area, right? So let me run
Yes,
that.
sir.
Let me just say for a minute, you had like a very small line, a small strip, right? Like a really, really small strip. Obviously this would have some dimension here. And to find the y value, I would take the x value and I'd plug it where? Where would I plug the x value? If I want to find the y.
Into the function.
Good. Into the function. And using this, I'll be able to find this very, very small area over here, right?
Yes, sir.
Then I would do it again. Then I would do it again, again. I would do it again. And I'm just gonna keep going, keep doing this until the upper bound.
Okay.
And to find the area, I'm just gonna add these like really small areas. That's what integration actually does. That's what
Oh, wow.
integration actually does. Yeah.
Well, thankfully there's integration, because imagine doing that over and over.
You'll have to do it in upper six when you're looking at trapezium rule. And
Oh my God.
if you do numerical techniques, you'll have to look at Simpson's rule, which is essentially what I just showed you guys.
Oh, okay, that's cool.
That's what
I
Simpson's
remember.
rule is. Because back here, what, right? Before calculus existed, if you wanted to find the area under this graph, what you'd have to do is you'd have had to consider a bunch of small rectangles or like trapeziums, and you would have had to like manually, you know, but you can see how this is not entirely accurate. Like in some instances, you have like a underestimation. This is not the most accurate thing. And of course, when the apple hit Isaac Newton, he figured out a better way to do it. Yeah.
Oh, thank God for that apple.
I'm going to the apple.
Yeah, so Cassidy, you understand what dx means graphically, right? It's just like the change in x, like
Yeah.
from one place to another place.
Yes, sir.
All right, cool. Anyways, Kamaya, we have 5 multiplied by -1 minus 7x to the power negative a half plus 1. What's going to go in the denominator?
Well, 3/2.
Nah,
Which,
take it time.
well, no, minus 3/2, which is minus a
Take your
half
time.
plus 1.
Take your time. What's negative a half plus 1? Negative a half plus 1.
Negative 3/2.
Now, imagine you had a whole pizza and somebody
Oh, yeah.
minus a half. Much of the pizza you have remaining?
Half.
A half, right? So, you have a half here, and I'm going to multiply that by what?
5. No. -1. No.
Nah, take
Minus
your time.
7.
-7, yeah.
Yeah.
When everything is said and done and you simplify this, that's gonna be 5 all over -7/2, which is 5 by 2 over -7. So you're gonna end up with -10/7 -1 -7x. Did anybody get this?
Yes, sir.
But I did the square root at the end. No, just to be a little extra.
That's good, that's good. Because it's an easy one, right? It's an easy one. In Cassidy, like, you know, until they could see that this is
Yeah.
a half, and you could just, yeah.
That's good. Yeah.
Cassidy, you sure you're okay with these type of questions? I do see they're bringing it harder than this. Like, of course, they could bring
Okay.
some roots, They could bring cube roots and whatnot, but it's the same concept.
Yeah, same concept.
Are you sure you understand?
Yes, sir.
Now it's just up to you to practice.
Yeah. So you have just like a bunch of these questions like these that you know
I should.
send on the chat.
Let me check my crash course notes for AdMats. I made a bunch of worksheets. Give me a second. And well, of course, I have this book here that has everything arranged. So like you could just do a bunch of differentiation past paper questions. I think I sent this before, did I not? Oh,
Yeah, yeah.
they'd have a bunch.
There's so many behaved children in the chat.
I will send it in the group chat with everybody there. Give me a second. I have worksheets with every topic. Just look for it. Where is that? Where is that? Yeah, I have a bunch. I just can't seem to find it. Where is it? Come on.
Go, Kylie, go. Good job, Kylie. You're doing amazing, sweetie.
What? Well,
So you need to get on the get on TikTok and look at the niche memes.
I will do that.
So they
Yeah.
like to watch Casio memes.
That's true. You would not be wrong in saying that.
I was
Um,
gonna call him an unk, but then I might get put out, so I'm not
Yeah,
call
yeah,
him
yeah,
an
yeah.
unk.
You get put out.
He's not an unk, so
Thank you. Yeah, I'll send this. Just remind me. I'll send. Have a bunch of questions here. A bunch.
okay, great. Greatness.
And I have the solutions too. I'll send it to you. As well as this.
This is wonderful.
All right, cool. So we're done with these types of questions. Good. Determine the coordinates of all the stationary points of the curve. Now, what is a stationary point? At a stationary point, the gradient is what? What's the gradient? Does anybody know?
0.
And if you are confused, let me give you an example quickly. What kind of curve is that? Anybody want to tell me? What kind of curve is that?
A parabola.
Yeah, maximum and minimum.
Maximum.
Right. So remember, when you're finding the gradient for a curve, is it the same everywhere or is it constantly changing?
Constantly changing.
Right. So the gradient here would be this. Let's stay with me. So you see that as we move, the gradient is changing. And when we reach the top, where's the gradient here at the top?
0.
Kamaya, do you remember that the gradient is tangential to the point you're interested in from last class? The gradient of the at the point is always
Yes,
formed by the tangent. So at the very top over here, the tangent of that would actually give you a horizontal line. And what do you all think the gradient of a horizontal line is?
0.
0.
It's 0. And remind me, what's another way we could write gradient? Instead of saying m, you could actually just write what? In terms of hard maths.
dy dx.
Right here.
Yeah, dy dx. So at the stationary point, the dy dx is actually equal to what?
0.
0.
And this is like the whole point of this, right? If I had a minimum graph, same concept. Over here would be the stationary point. And at this point over here, what would the gradient be? What would dy dx be?
Also 0.
Exactly, also 0. Now, the second derivative which just means you're going to differentiate another time. That's going to tell you the nature, right, of the turning point. So if the second derivative is less than 0, it'll actually be a maximum. And if the second derivative is more than 0, what do you think that would be?
A minimum turning point.
Exactly, minimum. So Cassidy, this is literally it. This is literally it, right, Cassidy? As this is all it is.
Great.
From here, it's just regular algebra, functions, and whatnot. Remind me, guys, if I want to find a y value, given an x value, what would I do? Virginia, I know you want to unmute. Stay quiet. I know you know it. I know you know it is. Guys, if I want to find a y value given an x value and I have a function, what would I do?
Put my x value into my function.
Right, that's exactly what you would do. And why am I saying that? Well, in this question, they're asking you to determine the what? Determine the what?
Stationary points.
The coordinates, and a coordinate is made up of what? What's a coordinate made up of?
X and y value.
Right. So the easy part is finding for x. Then, of course, to find for y, you'll need to take the x value you found and plug it into the function. So, Cassidy, I want you to tell me, what am I going to do with dy dx is equal to 0? What am I going to do with that? How am I going to help me here? How is that going to help me?
Put 0 into my function.
Nah,
Wherever you
I want you to read this one.
dy over dx equals to 0.
Right. What does dy dx tell us to do? What does it mean?
Gradient, change in y over change in x.
Good. And it also means the first what? It's the first what?
Derivative.
Yes. Yes. Dy dx is the first derivative. Now, here what? In maths, you should always be thinking, how could I form an equation? Because, of course, if you form an equation, you could do what?
So,
You could solve the equation, right, Cassidy? Cassidy, and if you make an equation, you could potentially solve it.
Yes, sir.
Cassidy, if I plug in 0 into this, what am I doing? I want you to think about it. If you plug 0 into this, what is that doing?
Nothing really. Yeah.
Yeah. However, Cassidy, and we know for a fact, at the turning point, the gradient will be 0.
Yes, sir.
Right. Now, for a curve, is the gradient the same everywhere?
No, it changes throughout.
Right. So you'll actually have to do what? What would you do to get the gradient function? You'll have to do what?
Find the second derivative.
Now, find the first derivative. When you find the first derivative, you're finding the gradient function. Right?
Right.
The answer is right there. Check it out.
Great.
All you have to remember is that dy dx is equal to 0. That's all you have to remember. So, dy dx tells you have to find your what derivative.
First derivative.
And that, what you get will be a gradient function. And you're trying to find stationary points. Then you'll set your gradient function equal to what? What will you set your gradient function to?
My stationary points.
Nah. So, what's the
Wait,
fact
can
we
you
know?
repeat the question?
No problem. What's the fact we know over here? What's the fact we know? What's the fact?
Dy dx equals to 0. So my gradient is 0.
The gradient is 0. So you'd have to find the first derivative to find the gradient function of the curve. And you are trying to figure out where the gradient function gives you what?
0.
Yes. Yes. Because we are trying to find the stationary points. In other words, what value for x in the gradient function is going to give me?
Would give me 0.
Yes. That is it.
Oh, okay.
Yeah. So here what? You have to find the what? We gotta find for first.
My first derivative.
You gotta find the first derivative first. Good. So we have a function y here, and we need to differentiate it with respect to the variable what? What is the variable here?
X.
Right. So we're going to differentiate the function y with respect to
X.
good. And this dy dx really is your what function? What function is that?
We just talk about it. My gradient.
Yes, because dy dx means gradient. And of
Yep.
course, for a curve, the gradient changes at different values for x. Hence, we need a gradient function. Because an a function could accept an input and give you a different output.
Yes, sir.
So like it accepts multiple different inputs and of course gives you multiple different outputs. That describes a function. Granted, you have one unique element. A function can only be a one-to-one or
Relationship. Yeah.
yeah. Keisha was something like that the other day, right?
Yeah.
Right? Everything in maths is connected, by the way. Everything. Yeah, so dy dx, this is a gradient function. This is a gradient function. Of course, we need to differentiate. Kamaya, alright. Kamaya, let me show you how we're going to differentiate. So when you're differentiating, you're going to multiply by the power and then take away one from the power. Now, Kamaya, remember last class, we actually looked at the concept behind it, differentiation from first principles.
Yes, sir.
So here's what. The mathematicians would have run a racket. Well, I can't say run a racket, right? They would have done multiple tests with first principles and they would have recognized a pattern. Now, first principles is the proof. Obviously, you're not going to do the proof in the exam. You're just gonna utilize what was learned in the proof. So let me explain. Come on, in the last class, you had y is equal to 5x plus 7. When I differentiated that using the long thing, I get 5. See now?
Yes, sir.
So that is the y. Now we're going to use it. Now we're just going to use it. In the exam, you're just going to use it. So let me show you what I mean by that. The general pattern is that when you differentiate and you multiply by the power, and then you minus 1 from the power. So what is a third by 3? As the first step, what's a third by 3? So a third by 3.
1.
That'll be 1. Cool. So that'll just be 1. And then a minus 1 from the power. What would that be?
2.
Cool. Cassidy, if I differentiate minus 5 over 2x, what would I get?
Wait, differentiate. So I'll multiply minus 5 over 2 by what's the power 2, and I'll get I'll get minus 5, and then I'll minus 1 from the power, so it's just being minus 5x.
Correct. Minus 5x. And, well, in the last class, we'd have proved this, right? We'd have proved this. Of course, you would have seen it for yourself. If you are differentiating something like 5x, the rate of change of the function is 5. So when you find dy dx, you're just going to get 5. So, guys, when I differentiate 4x, what would I get?
Just 4.
Come on, are you okay with that, right? If I differentiate 4x, I'll just get 4.
Yes, sir.
And I have a question for you all. We have minus a half here. Does minus a half ever change?
No.
Cassidy, does minus a half ever change?
No, sir.
So what do you think the gradient for minus a half is? What do you think the rate of change is? If it doesn't change, what would the rate of change be?
Constant, so it's 0.
Yep, 0. That's why when you differentiate a constant, it's 0 because it's not changing. The rate of change is 0. It will always be minus a half. So Cassidy, let's run through this. When you differentiate, you multiply by the power, and then you minus 1 from the power, right?
Yes, sir.
You sure you're okay?
Yes, sir.
And this makes sense because everywhere you look on the curve, the gradient is changing. So obviously we'll model the gradient by using our function. And now we are trying to find the value of x that makes dy dx what?
Zero.
Yes. So we are trying to figure out the input that makes the output, which is the gradient, 0. So
Great.
now I'm going to set this entire thing equal to
0.
good. And from there I could,
So
yes, let's solve.
Wait, so I just have one question.
Talk to me.
Um, I figure like why we multiplying the power by the coefficient.
So remember I was telling you that wait, let me run back. Let me just look back at this again. Give me a second. So in the last class, we would have looked at first principles, right? And this would have been the concept behind differentiation. When you do first principles, certain observations will be noticed. Let me give you an example. Let me just say we had f of x is equal to x squared minus 3, right? After
Yeah.
the long working, you realize that you just get 2x.
Mm-hmm.
So instead of doing this, all of this, you're going to utilize the trends you would have observed. But the reason why you're doing that is because of this process over here, first principles. But you're not going to do it for every single time. You know what I mean? Like, okay, let me see if I could explain this to you. Cassidy, I feel like this is a good like, don't want to get Kim involved. I was gonna talk about catalysts.
I
yeah,
don't know what catalysis is.
mentioned. Chemistry mentioned.
That was if catalyst would be the best thing to use. Okay, I have a good one, Kamaya. I have a good one. So Kamaya, let me just say hungry night, right?
Yes.
Let me just say it was in the 90s or the 80s or the 70s or whatever. You're hungry night. You're out of gas. Well, let's just say you have gas, right? Things are that rough. You have gas. And you gotta go and pull up the stove and heat up the food like normal. It take time, right?
Yeah.
Let me just say in modern day, right? You have a microwave. What you could do if you're hungry in the night? Would you use the microwave or would you heat it up like with the stove on thing?
A microwave.
Exactly. So here what I say, this is already proven. We already know that if I differentiate x squared, I'll get 2x from the long method. So now we're just utilizing what we know.
Yeah.
So if I differentiate x squared, I'm gonna multiply by the power, because that's what happens when you do first principles, and you're gonna get 2x to the power 1. So generally speaking, Kamaya, when you are differentiating x to some power, the general rule is this. You're gonna multiply by the power, and then you would take away 1 from the power. And that is what was observed by doing first principles. Which is like the full long working.
So, okay, I understand that part, but like in the f of x equals x2 minus 3, where did 3 went in this whole thing?
No problem.
Or is 0 because it's a constant.
Yes.
Not changed.
Let me explain something, right? dy dx, it tells us how y changes with respect to x. Let me explain. In a function, if you change the value for x, would the y value remain the same or would it change?
You can repeat?
Okay, if you have a function, right? And you put different values for x, are you going to get the same output?
No, sir.
No. So there must be some way to measure the rate of change, comparing y to x, right? That's what we're doing here when we differentiate. Now, look at the minus a half. The minus a half is a constant. Is there anywhere there where I could put in an x, or will it always be negative a half?
It'll always be negative a half.
Right. So the rate at which that changes is 0. That will never change. That will never change. That's why over here you didn't see I put anything. I just put plus 0 and I ignore it. 4x will change at a rate of 4. Minus 5 over 2x squared would change at a rate of minus 5x. A third x cubed would change at a rate of 1x squared.
Yeah.
Right? And this over here is your gradient function. We are trying to find the stationary point where the gradient is. Somebody remind me. At the stationary point, what's the gradient?
0.
Cassidy, you have that locked in, right? The gradient is
Yes,
0.
sir. 0.
Good. And again, what we have here is actually a function, a gradient function. So different values of x will give you different outputs, different gradients. But again, we're trying to find where the gradient is 0. So that's why I set it equal to 0. Now I could solve. So I'm going to solve this quadratic real quick. So we have x squared. So to get back x squared, I could say x by x. Then I'm going to look at the last number. The last number is 4. Cassidy, is there any way I could multiply to get 4?
Yeah. And I'll have to add to get minus 5, right?
Correct.
Minus 1 times minus 4.
Yeah. Good. So minus 1, minus 4. And so, how would I solve this now? How would I solve this now? Cassidy?
Replace plus 4 with, well, x and 4x.
Nah. So, we are trying to figure out the values of x that will make this give us what? What is that equal to?
0.
That's equal to 0. So we have this product. We have these two things multiplying by each other. So remind me, Cassidy.
Oh,
0.
wait. Let me cook.
Okay.
So I have x minus 1 and then x minus 4. So I'll have x minus 1 equals 0 and x minus 4 equals 0. And then x would just be 1 and x would be 4.
I think you could explain why though? Why are those answers correct?
Well, you take over the minus 1. You carry over the minus 1 on the other side and then become plus 1, and then you carry over the minus 4 on the other side, become plus 4.
But why? Why are we doing that? Like, how I know these answers correct?
That was what they told me to do in school.
But you ever wonder why you're doing that?
Yeah.
Right. So over here, you factorize the quadratic, meaning that you've written it as a product of. You write this as a product of what? When you factorize it, you're writing something as a product of its.
Wait, you lost me.
Okay. Could you agree that we factorized the quadratic?
Yeah.
Right. So anytime you factorize something, you're writing it as a product of its factors.
Oh yeah.
Like, I'm gonna show you an example, like 20. 20 is the same thing as 5 by 4, yeah?
Yes, so
5 is a factor of 20 and 4 is a factor of 20. The same way here, how x minus 1 and x minus 4 both factors are x squared minus 5x plus 4. Now, the reason why we want to do this is because anytime you have a product and it's equal to 0, either one of the factors could be 0. Let me explain why. If this whole bracket gives you 0, what's 0 by anything?
here.
So Cassidy, here was in, right? Yeah. If this whole bracket gives you a result of 0, do we care what we multiply the 0 by in this bracket?
No,
No, because 0 by anything is.
it's 0.
And let me ask you a question. When x is 1, what happens to this bracket?
What?
Yeah, when x is 1, what happens to this bracket? What does our bracket turn to?
Oh, 1 minus 1, 0.
0. And then that 0 gonna multiply by what?
Oh, well, by x minus 4, but it don't matter because
Don't
they're
matter.
gonna just be 0.
Exactly. So that's why you're setting the linear products equal to 0, because once you have a product of factors and you had to get 0, it's true when at least one of the factors is 0. Why? Because when this is 0, you're multiplying. Product of factors means you're multiplying each factor. And well, if one of them is 0, what I mean? If one of them is 0, what I mean?
Well, if one is 0, then it don't matter, like, it automatically equal to 0.
Automatically, you're going to get 0. So that's why you
Yeah.
set the factors equal to 0. Over here, when x is 4, what happens?
4 minus 4, 0.
And then they're going to multiply by what?
Well, it don't matter because it's just gonna be equal to 0.
Exactly. So you see why we set it equal to 0 now?
Yes, sir.
Good. So, question. If I were to plug x is equal to 1 into my gradient function, wouldn't that tell me the gradient I'm getting when x is 1?
Yes, sir.
And what should I get if I'm correct?
0.
I should get 0, right? Let's see. Well, we know it's going to be 0, right? Because we factorize it and we get 0, but seeing is believing, right? So I'm going to plug in x is equal to 1 into this. So I'll say 1 squared. Well, you tell me what to write next for 1 squared.
Oh, it will be 1 squared by 1.
Wait, I ignore any one there. So I'll
Yes,
just
sir.
plug in the
Oh, okay. Minus 5 by 1 plus 4.
and if I'm correct, what I'm supposed to get?
0.
Because I want to find the stationary points. At the stationary points, the gradient is
0.
whoa.
Oh my
Right.
gosh.
And again, if you have trust issues, what other value for x you could plug in into the gradient function?
4.
4. So I'll say 4 what? That's
4 squared minus 5 by 4 plus 4.
And if I'm correct, the gradient supposed to be
0.
yeah. I hope you understand why anytime they ask you to solve, you have to factorize. Because what easier to find the roots for, this or this?
The other this, not the first this, the second one.
Exactly, because when you write something as a product of factors, you know it's true when at least one of the factors is equal to
0.
exactly. That's why you factorize, and that's why factorization is helpful, because it allows me to break up my expression into like the product of like the simplest terms, and I could examine each term separately. You understand?
Yes, sir.
Cool. So here what? You have x is equal to 1 and you have x is equal to 4. But do you think we're done?
No, I need a y value.
How are we going to get our y values? Come on.
Put my x value in some function.
Am I going to put it into this?
No, the original thing.
Exactly, guys. Come on, will this give me y? Oh, what will it give me?
It would give you the gradient.
Yes, it will give you the gradient. Because it's the gradient
Yeah.
function. Good. But do we want the gradient?
No, sir. We want
No, we
the
want
y.
we want the
And the
y
coordinate.
value. Good. So I'll as we're seeing, y is equal to this, so you'll plug it into that. Cassidy, you see how maths is a logical kind of thing? It is.
So, do be comment for my subject.
Sorry.
Yeah.
My mother, I know, doesn't want to beat me too, because she's a chem teacher.
Yeah. I'm gonna be best friends with her.
That's good. I feel like we are up here into the family.
Yes, and I'll become an inside child.
I suppose so. I called him when I was telling she probably just be calling. Well, your mom tell we self she say that how you just be calling the Shana. Moms and all kind
Yes.
yeah, boy. So that's gonna be a third by 1 cube minus 5 over 2 by 1 squared plus 4 minus a half. I'm getting 4 over 3. So what is my first point? What's my first point?
1 4 over 3.
Good. 1 4 over 3. Anybody want to tell me how I'm going to find the other point?
Do the similar thing, but plug in x equal to 4.
Mm-hmm.
So why do we have to prove both?
So like,
Never mind.
if there's one thing I like about you, come on, it's like you just question everything. That's like a sign of high intelligence.
Yeah, and then everything does just fall out when I see the test paper blank.
Don't know why that has happened.
Mm.
That has happened to me too. So
I
you're not
thought,
alone for that.
well, it was the exact same case with me. Like when I write my first art maths exam, I get 40 something, and I thought I know everything. And as a matter of fact, I was teaching my friends anything, but like, I don't know what had gone wrong.
That really happened to me the first term of Form 4, bro. I was teaching people left, right, and center,
I
and
was
then I come
cooking.
I get 50 something.
I
You
was
do better
cooking
than
all
me,
day.
but come on, you do
I
better than
failed.
me. I get 40 something on your bodies.
No, yes. No, come on. Yeah, you do better than me. I feel for you. Bad.
Oh, I
Yeah.
just try just not to feel. I can't reach quite down there. At least I ever get 50 something. The only thing I ever feel in my life is library. All you know library is a class.
What?
Did you all know that? Yeah.
Why does
In
that
Form
class?
1
From
to
you saying that, I think I know what school you're going to.
which is
You go to Miracle Ministries?
no.
Oh, okay. Library is like a big thing in Miracle Ministries.
I don't understand what's the point, but they just teach you the do decimal system and random things.
That's crazy. Inches goes sour or
Let's go St. George's College.
okay.
Yeah.
That's a strange answer I get in.
So I didn't get that.
I didn't get that either.
Something wrong with me then. A third 40 power
10
3.
to the power 2.
Oh, Bumbo. Anyway, I get that.
Yes, sir.
Yes, sir.
I don't want Shayna and the rest of them to be feeling left out. Don't worry. After I don't want Cassidy here, I will focus on you guys. Don't worry. Nobody is left out. If I stay long enough, I'll get the help you need. Now hear what? You know what they say? Seeing is what? Seeing is what?
Believe in.
Right. Now let me explain something. What's the highest power of x here?
3.
3. Now in an ideal world, that would suggest that it's cutting the x-axis at how much points?
3 points?
Right. And now Cassidy, let's get down to y. Cassidy, if the highest power for x is 3, it suggests that I would have how much linear factors?
3.
Exactly, because you'd have x in some
I
bracket
wouldn't
by
believe how
x
I
in
know the answer to this question.
how?
I was looking at the cash course today and Kilani talk about this. And it's sticking my brain.
That's good. Cassidy, Kilani is teach good too. Right? So think of it like this. I just tell you factorization is important. If you notice, to factorize x squared, you see like you end up with one bracket with x and another bracket with x. So it makes sense if I wanted to factorize x cubed, I would have x in one bracket, x in another bracket, and x in another bracket. And that would result in x cubed. You understand?
Yes, sir.
So if I have 3 linear factors, I'll have 3 x-intercepts. So in an ideal world, your graph will look something like that because at most it'll cut the x-axis at 3 points. Now when you look at the general shape here, what are you all seeing? You're looking for what's on our what's. Let me see if I can figure it out.
Minimum and a maximum.
Yeah, the maximum over there and the minimum is over here. So that's why we got two stationary points. Hope that sinks in. Again, that's why we get two stationary points because look at the general shape of it. One up, one down. Let me see. Let's graph it. I can tell which one is the minimum just by looking at it, so no.
Yeah. Ah, never mind. Yeah.
I can't.
Cassidy, you see I can't? But that was Virginia.
That was Virginia.
That was me.
Alright, so Virginia, when you hear minimum, let me give a real easy way to remember this, right? When you think of minimum, you think of it going low or high?
Low.
And you think we're looking at the X value or the Y value?
X.
Oh, okay. What?
Looking at the Y value, right? So if something, let's compare these 2 points, right? Just thinking about it, you would say that this point is a what, maximum or a minimum?
Oh, that one would be maximum.
This is a maximum, right? Just by looking at the Y value. And you would say that this is a what?
Minimum.
So what I'm trying to say is, if the Y value is bigger, chances are it's a what?
Maximum.
Yeah. So look at it now and tell me, which one is the maximum?
Oh, the first point.
First one. Just by looking at it, I could tell that this is the maximum. You know why? Because you tell me. As a matter of fact, you tell me.
Because it has a greater Y value than the second point.
Good. Everybody okay with that? Are they seeing that?
Yes,
Cassidy,
sir.
Cassidy, can you imagine that this dips down quite to minus 19 over 6 when this one goes up to 4 over 3?
Yes, sir.
Good. Now again, seeing is believing, so let's do a sketch of the graph. So y is equal to 1 over 3. If I do any funny business, somebody would tell me, right? Like, I have a habit of plugging in things wrong. Does that look like a cubic?
Yes, sir.
Is that what we predicted?
Yep.
Yes.
sir.
Until they see a maximum and a minimum.
Yes, sir.
sir.
Yes.
How much
sir.
time the graph? How much time the graph cuts on the x-axis?
3 times.
3 times.
3 times.
Of course, we call that. When I tap the maximum, what do you think the maximum is supposed to read?
Over 3.
Over 3.
Well, we know 4 over 3 is 1.333, right?
Yeah.
Right? You know what? Let me just plot this. So 1, 4 over 3. Are you seeing it?
Yes, sir.
Next one. The other one is 4, comma, minus 19 on 6. Are you seeing where it's supposed to be? Is it where it's
Yeah.
supposed to be?
Yes, sir.
Alright. Everybody okay with this?
Yep.
Are they sure?
Positive.
I know somebody didn't do this as yet. People that did do it, let me know if this reinforces what you know, like, be honest, like, Cassidy, understand what happened?
Yes, sir.
You sure?
Yes, sir.
Okay, now Cassidy, you take the dance floor and you explain to the class how to do the question so that when you're in the exam, you wouldn't crash out. This is the time
So
to
you wouldn't believe, right? Mommy just give me chow. I'd have pepper in it. But here's what I'm going to push through.
That is good. This is training for exam conditions, and Virginia is
Right,
like
right.
training. It's like training. If anything,
Yes.
I'm gonna tell your mother to give your bulldog spicy ramen. You know what I mean? If you could
No,
focus
no,
through
no,
that, if you could focus through that, yeah, you're that boss, you're that soldier. You're that soldier.
All right. I'm a real G. All right.
Yeah, yeah, real G.
I'm gonna unlock my inner Sarah. So the
This is so
question
bad.
asks, determine the coordinates of all stationary points of the curve, right? And then they give us y is equal to our function. So boom. Now you see that little sketch that Sir do in the corner over there, maximum and minimum graphs. Basically, at the maximum point, we're telling you that the gradient is 0. At the minimum point, our gradient is 0. So you see that little dy over dx, the first one is equal to 0. That's your first derivative. Your
Mm.
first derivative has to be equal to 0. Because, when the point is stationary, your gradient is equal to 0. Okay, so boom. dy over dx of the function that they give us is equal to 1x squared minus 5x plus 4. Now, since we said that our first derivative, which is, I still have the little arrow over there, the gradient function, our first derivative has to be equal to 0, which means our gradient is equal to 0. So since we found the derivative of the function that they gave us, and we got x squared minus 5x plus 4, we're going to put that equal to 0 because our gradient has to be equal to 0. After that, we factorize. We end up with x minus 1 and then x minus 4. After that, we find our two x values. We have x minus 1 is equal to 0, which makes x equal to 1. And then x minus 4 is equal to 0, which makes x equal to 4. Now we plug in 1, well, for our first x value, we use 1, right? We plug in 1 into our original function. Because remember, when we find x is equal to 1 and x is equal to 4, they want coordinates, and coordinates are made up of an x and y value. So we still have to find our y value, even though we have our x values, right? So you see that x is equal to 1. We take that 1 and plug it into our original function. Not the derivative, the original function. So when we do that, we'll end up with y is equal to 4 over 3. So since our x value that we plugged in this equation was 1, our coordinates would be 1, 4 over 3. Our next x value is 4. We plug in 4 into our original equation, we end up with y is equal to minus 19 over 6. And since our x value over here was 4, our coordinates would be 4 and 9 minus 19 over 6. Now let's just take a look at our y value and our y values for our both coordinates, right? We realize 4 over 3 and what? Minus 19 over 6. So we have a maximum and a minimum graph occurring here because 4 over 3 is more than minus 19 over 6. So minus 19 over 6, our curve would dip lower compared to 4 over 3, which would go higher on our graph.
I think that was a really good explanation. What do you think? How did she do?
And so
Excellent.
too.
Yeah, I find that was good. So come on, yeah, you see,
Oh
in good
man,
hands for
this was
chemistry.
like,
In good hands.
Yes,
yeah,
sir.
and now my mouth not on fire actually. That was crazy.
That was good. It was good. It was literally on fire, and it was cooking. Yeah.
Right.
So after I do these questions, Sheena, you there? Sheena, talk to me. Feel like poor Sheena. Sheena, you feeling left out? Sheena,
Only a bit, okay.
don't worry, Sheena. After I do these questions with Cassidy. Don't worry, Cassidy. I know your name, eh? I just don't know why. It's happened. It's happened. I just
Yeah.
have
I
like
know, I know.
this brain fog, you know. We'll do the worksheet that I got, right, Sheena? Yeah.
On my son? Sure.
And that worksheet actually it hits. Until you know about Venn diagrams, right? There's a lot of intersections happening here when they compare the batches. And
Yeah,
Virginia, don't worry. I'll make sure that you get the help you need as well as the other people. Cause
I'm not worried at all. Don't worry. I trust.
and I'm not worried about you either. Like you get like full marks in the differentiation exam the other day. I really not concerned. I know you're gonna do good anyways.
I need the guidance, I can't be too small headed. I did all right. I got full marks because of maths vibes.
She's trying to play nonchalant and humble, you know what I mean? I like that. Right? Part 2. Hence determine the nature of each of the stationary points found in B part 1. Cassidy, wouldn't have it been nice if you could have just say minus 19 over 6 is less than 4 over 3, so it's a minimum.
Yeah.
Yeah, but you don't want that.
No, with that maths though.
They want the second derivative. But you understand how you could use this to check to see what your answer should be, right?
Yes, sir.
All right, so here what? When they're asking for nature of each stationary point, they really want you to find the second derivative, because that will tell you the nature of the stationary points. So that would be d2y dx squared. Yeah, you with me?
Yes, sir.
And that just means you're going to differentiate another time. So you see how we had dy dx here?
Mm-hmm.
I want you to differentiate that another time for me. Differentiate that another time.
2x minus 5.
That's all. Yeah.
Yep.
So, and now you're gonna plug in the values for x. So you'd say when x is 1 and the other value for x was
And
4,
then
right?
when x is 4, yeah. When x is 1, you'll end up with, well, 2 by 1 minus 5, which is minus 3. And then 2 by 4 minus 5, which is 3.
So 2 minus 5 is,
This is minus 3.
so that's a maximum or minimum.
Um, Minimum.
Nah. If it's a negative, it's a maximum.
Maximum. Sorry. I
You see,
remember the frowny face.
and you see why this hack is so important? Like,
Yeah.
here what, right? You could do the second derivative and then forget which is which, right? This would ensure that you
Yeah.
don't forget. To secure that, you know that one that other one mark. So this is your maximum. 1 4 on
Mhm.
therefore 1
And then this one would be, well, yeah, 2 by 4 with minus 5, which is 3.
So therefore, you would say that 4, comma, minus 19 over 6 is
Minimum.
here. Okay with this, right?
Yes, sir. I remember the frowny face and the smiling face for max and min.
Good. I mean, matter of
Yeah,
fact,
yeah.
let me show you something, right? You know, that is why they just say if it's negative is a maximum and if it's positive is minimum because it's second derivative. Did you know that's
Yeah,
why?
yeah.
So like if you had 5x squared plus 3x plus 7, this okay, first of all, this only has one turning point here because it's a quadratic. So when you find
Yes,
dy
sir.
dx, you get 10x plus 3, and of course, when you find the second derivative, you just get 10. So of course, second derivative is positive, so that's why it's a minimum. But in maths, they just boil it down even simpler. You know, if A is positive, it's a minimum. If it's a negative, it's a maximum.
Yes, sir.
Cool. I love these type of questions. These questions nice. Just make you think. So, by the way, Cassidy, the solutions for the 2026 May June AdMaths exam is on my YouTube channel. And
Great.
I do it in detail with Virginia. So you go look at that.
Okay, no problem.
So let me just send in the group chat one time.
You know, still on the grind and thing, the hard math never stops. But you know, Brazil playing Haiti tonight, and
Oh,
you know, I think the grind might have to have a little halftime, you know, so
halftime.
I can, yeah.
Hmm.
But I feel like Brazil need to make a comeback from whatever happened in that first match
For
because
sure. Brazil. Hey, you ever see like how naturally talented them Brazilian people is when it comes to football?
yeah,
It's like
yeah.
some random
I mean,
person on the streets could do some.
kicking ball barefoot.
It's crazy.
And you know what gets into me? It had so many people, it had 8 billion people in the world, and they decided to choose Ollie to play for the Brazil team, and now they went there and embarrassed themselves. Come on, man.
It's crazy. I feel like these Brazilian people have natural talent. It's like, it's like it's in their blood. Yeah. Right? You know how Asian people just the stereotype is Asian people good at maths. You know, that's the
Brazilian
stereotype.
people good at playing football.
Yeah. They just yeah. All right. So Cassidy, after this, you'll never have problems with rates of change ever. I promise.
You promise? You think you promise? Okay, great. I believe you.
Are they all believe me too? Other people?
Yes, sir. Definitely. After that live, I believe you 100%.
That's good. That's good. So, Cassidy, I want you to read this.
The length of each edge of a cube is increasing at a rate of 0.25 centimeters per second. Calculate the rate of change of the volume of the cube at the instant where the length is 8 centimeters.
Whoa. When you read that, your brain must be like, fuck!
Yeah,
You know what I mean?
like that meme I sent you today. What would you
Fuck!
do if Kate or she said yes would go?
It'd be like, sometimes I just be surprised my ADHD brain could comprehend these things and teach it. I'll genuinely
Thank
be
God,
surprised.
yes. So a rate of change question came in the last course that we had to do, right? And like 3/4 of the class left out the question. I was included in that
Well,
3/4. I'm so sorry. I
You'll see how
apologize.
you'll see how
And
easy it is,
then
right? It's real easy. Check.
yeah, after class, Stu was explaining how easy it was to us, and we were very ashamed of ourselves.
Well, look at it. I'm gonna show you the hacks, right? This is the hacks. So I want you to think of this. So it's gonna be what you're finding for equals to something by something. And of course you'll get the hints from the question. So they're saying the length of each edge of a cube. What do you want to call the length? S or L? What do you want to call it?
L.
L? Okay. So they're saying that the length is increasing at a rate of
0.25 centimeters per second.
right. Look at the units. It's centimeters, which implies what? In other words,
Measurement.
Cassidy, wait, they're saying the length of each cube is increasing at a rate of 0.25 centimeters per second. So that's telling us that the length of the cube is changing with respect to
Time.
exactly. And you can see it from the units. It's centimeters per second. What do you think these
Yeah,
centimeters measuring?
the length of the cube.
The length, correct. So this 0.25, it's actually the change in length with respect to
dt, change in time.
exactly, and that is 0.25. I'll forget what the units for now. But I want you to understand that I'm using the units to come up with the derivative notation. Right? Let me run it back again. So Kamaya, do you understand that when I tell you the length of the edge of a cube is changing, doesn't that mean as time passes by the length changing? So that's dl over dt. The change in length with respect to time.
Yes, sir.
Shina, think of it, think about it. Imagine you were filling water into like a fish aquarium. As time passes by, what happens to the length, the water level, and the height of the water level?
Will decrease.
It increased, right? So Shina, in other words, the length is changing with respect to the
Volume.
time. As time passes by, the length will increase. So Shina, I want you to read this. You'll have to do this anyways. So I want you to read it from Shina.
The length of each edge of a cube is increasing at a rate of 0.25 centimeters.
And what does this mean?
So my physics flipping just now.
Anytime you see s to the power negative 1, I want you to read it as per. Because s to the power negative 1 really means 1 over.
So I know this, but my physics brain slipping.
So much here now will be 1 over what? S to the power negative 1 indices.
Yes.
Good. So it will be centimeters by 1 over s, which is really centimeters over s. So this, our way to say it will be 0.25 what?
Centimeters per second.
Good. That implies that centimeters is on top and what's in the bottom?
Seconds.
Exactly. So as you can see, what does centimeter measure? Like centimeter measures what? What's physical
Length.
quantity? Length. So as you can see, the length is changing with respect to
Time.
right. So Cassidy, you understand how I dissected that part there?
Yes, sir.
Good. So I'm gonna write that I have dLdt. This is very important. So dLdt is 0.25. Cool. Next part, Cassidy. I want you to read the next part for me.
Calculate the rate of change of the volume of the cube at
Wait, stop.
the instant
Stop.
where the
Then,
okay.
right, so they want us to calculate the rate of change of the volume, right?
Yes, sir.
Okay. When we're talking about rate, we're always talking about with respect to what? Does anybody know? Rate. Anytime I say rate, rate is always exactly rate. You measure rate using time, right? Anytime you see rate, just know that time is implied. It's changing with respect to time. Okay? Do you all understand that?
Yes, sir.
If you
Yes,
use
sir.
the word rate, it means that some quantity is changing with respect to
Time.
cool. And so here what? When they say calculate the rate of change of the volume, Cassidy, you think you could write that notation for me?
Yeah. dt over dv.
Nope. If you
dv over dt.
if you say dt over dv, you're telling me that
Time
the
with
time,
respect to volume. Yeah.
but that don't make sense.
So
How will
dv
time
over dt.
think about it, right? How will time be affected by volume?
I remember you talking about this during the video I looked at
I
earlier
did.
today.
I did like
Yeah,
okay,
yeah.
if I fill water in this bottle, am I changing time?
No, you're changing volume.
A change in volume, and just so happens the volume changes with respect to
Time.
exactly. It's always over time, not the other way around. It's always over time, right? It's always over time. So Cassidy, um, all that,
dv over dt.
and that's what they want me to do. What do they want me to do?
Right.
Say that again.
That's what they want me to find.
Exactly. That's what they want you to find. Now, in chain rule, you're gonna connect different rates of change. So here's what I'm gonna do,
Yeah.
Cassidy. I'm gonna multiply two different rates of change, right? So I know that I have to get dt in the denominator. So what do you think has to come over here for sure?
dt.
And what do you think has to come over here?
dv.
And now I want you to look at what we have. We were given this. We already
So
included dt. What other variable do I have?
dl
And if I have dl over here, where should it be as well to cancel off?
on the other side, underneath dv.
Because when I do that, I'll end up with what?
dv over dt.
Yeah. Say with me so far?
Yes, sir.
Okay. This is what I want to find for. I have this. What am I missing?
dv over dl.
I'm missing this, right? But I know how to find. Think to yourself, Cassidy, what shape we dealing with?
A cube.
A cube, yes, a cube. If it's dvdl, chances are you have to differentiate what function.
Wait, so you can repeat that, please?
No problem. So it's dv over dl, which means you have to differentiate what function? The function for what?
DL.
Now, so it's dv over dl, which means is volume with respect to length.
With respect to length.
Right, so what function would you have to differentiate?
DV.
V, volume,
Yeah.
volume. So we're dealing with a cube, right? And instead of using side, we're using length. So what would the function for volume be in terms of length?
Wait, we're not using side. So length by length,
Which is just what?
length to the power of 3. Length cube.
And good. And this is actually a function, Cassidy. This is actually a function.
Yes, sir.
Do you know why I'm calling it a function? Or you're just saying yeah.
Because you could input something for L.
Exactly, and you'll get a different volume.
Yeah.
Cool. As per the question, we need to find what?
DV over DL.
Right, so I'm gonna do what now?
We find the derivative of DV.
You find the first derivative. So you're gonna differentiate
Yes.
V. You're gonna differentiate V with respect to
L.
what would that be?
3L.
You have more to tell me.
2 power 2.
Right, before 2. And if you read the question further along, before I stop here, they said at the instant when the length is 8. So what am I gonna plug in for L?
8.
So that'll be what?
192.
Yeah. Right? So do I know what DVDL is now?
Yes, sir.
Do I know what DLDT is?
Yes, sir.
So that'll just be 0.25 by what?
192.
Cassidy, I have a feeling your teacher just gonna bring questions from 2026, you know? Because
I
like
feel so too to see. Yeah.
in 2026, you had a chain rule question. You had stationary points. You had to integrate something like where you gave me, and you had to do a rate of change question. Just watch the 2026 video. It's not even that long. It's 2
Okay.
hours and 54 minutes.
Yeah.
Yeah.
Okay.
Right? And what's 0.25 by 192?
48.
And let's look at the units now. It's volume over time. If our length is measured in centimeters, then what would volume be?
Wait, so you can repeat that?
Right, so it's volume with respect to time. If we're measuring length using centimeters, what do you think we'll measure volume in?
Centimeters cubed.
Right, so, and of course we measure in time in,
Seconds.
so units will be centimeter cube. You could say per second, or you could say what? Instead of saying per second, you could write S what?
SC minus 1.
You understand this?
Yes, sir.
All the questions is just like some version of this.
Yeah.
So let me run through it again. Look for what they're giving you. In this question, they give you DLDT. Put that on one time. Then you look for a way to find. Put that on one time. They want us to find DVDT. To get DVDT, I have to multiply 2 different rates of change. So I already have DLDT, put that there, and I have to get DV on top. So, of course, if you have DL over here, DL had to be here too. Why, Cassidy?
So that it could cancel out.
Exactly. DLDT was 0.25. You're missing DVDL. But that would have come from which function?
Wait, repeat your question, please.
DVDL. You're gonna get that by differentiating what?
DLDT?
Nah, you're gonna get this by differentiating volume with respect to length.
Oh, yeah.
Yeah.
We did that. We knew that.
Yeah. You do that, you plug in the instant when the length is 8, you get 192, plug it in, you get 48. So here, let me do the question from 2026. And I want you to take the lead, right? And after this, I will start with Sheila.
So you send all of this on the group chat, right?
Yeah, I'll send all this in the group chat.
Okay, great. Because I need to make proper notes.
No problem. I'm gonna send all of these solutions before I edit it. Cassidy, I bet you he gonna just bring 2026. Bet you.
I think he's the type of person to do that, so
Yeah, sure he gonna do that.
and then throw in the questions that he wants to make from on top of his head.
You'll have the formula sheet, right, for AdMats? I think I sent on the group chat or not.
No, sir.
Okay. I have a lot of things to send you. Okay, so Cassidy, give it a read for me. And
Yes,
of
sir.
course, you all are welcome to try the question in the meantime.
Greatness. I think this was a question that came on the test that he gave us, actually.
Serious?
Yeah, this is real familiar.
Well, let me do it.
Okay. Yeah. Okay. Each side of a block of ice in the shape of a cube is melting uniformly at a rate of a third centimeters per minute. At what rate is the ice block's surface area melting when the sides of the ice block are 150 centimeters? Include the units in your final answer.
Now, if I say something is melting, it automatically means that it's decreasing over time, right?
Yes, sir.
So it's a bit controversy. Some people would say like you have to put in negative. You technically don't have to because they explicitly asking you what is the rate it's melting at. So you're not gonna say negative, like you don't have to. You can just find the answer and say it's
Yeah.
melting at that rate because if I say it's
It understood.
melting, if I say it's melting at that rate, obviously it's not increasing, right? It's gonna
It's not
decrease at
increasing,
that rate.
yeah.
So there we go. Each side of a block, we want to call our side.
S.
You know what? I talk too much. I want you to take the wheel and try to explain it to me.
Oh, okay. Each side of a block of ice in the shape of a cube is melting uniformly at a rate of a third centimeters per minute. Okay. So the side of a block is melting at a rate of a third. So that's side with respect to time. So ds over dt. And that will be equal to a third centimeters per minute.
Everybody with Cassidy so far? Everybody understand why Cassidy said what she said or not?
Yes, sir.
Okay. Yeah, 1/3 centimeters per minute. Yeah. What next?
Okay. So At what rate is the ice block's surface area melting? I feel like seems like needs a higher English teacher. What going on? At what rate is the ice block's surface area melting when the sides of the ice block are 150 centimeters? Okay,
Every
so
yeah.
great. So and then they ask, well, they include the units in your final answer. They want to know surface area with respect to time still, because they say at what rates.
And rate always
So
implies.
time.
Mm-hmm. So
So they want us to find the, well, area, I'll just call that A. So dA over dt, that's what we need to find. So in order for us to be able to find dA over dt, we need to have something on the other side that would give us dA over dt. So we have ds over dt. So we could do ds over dt, and then we would need dt in the denominator of the other.
wait,
So
take your time. It
no,
just
ds under that denominator.
right.
So we'll have ds there, and we want dA over dt, so it would just be dA over ds. But I'm saying the letter B. So much D's.
Right.
Okay. So this is what, a cube?
Yeah.
So each side, so we have basically volume of a cube. So side times side times side, which is just side cube.
Wait. Whoa. Take your time. Where you get volume from? Let me explain that to me.
Oh
Where you get-
yes, we're doing surface area. I mixed it up with the last question.
Look at this.
You
Look at
know,
this carefully.
uh,
It's dA over
A,
dx. Meaning
yes,
you would have had to find the first derivative of what?
dA.
Area.
Yeah.
So
So surface area. I'll have my cube has 6 faces. I'll wait for you to draw your cube. You know, we have to include the visuals. Great. So we have, right, we have 6 faces of my cube over here, and we're trying to find surface area. So surface area of a cube is just 6 side square.
yeah,
Great.
because the
Um,
area of each side, each face will be s by s. We have 6.
yeah.
Everybody
Mhm.
okay with that? So the area is 6s squared, the surface area,
Yes, sir.
right? What next?
So we have to find the first derivative of area. So since A is equal to 6 sides squared, dA ds. Wait, so you can zoom out for a second. Okay, so dA ds is just, wait, 125? Hold on.
Wait, do the working first, so differentiate it first. If I differentiate that, what would I write?
I'll end up with 6 by 2, 12s. Great. So
What next?
dA ds is equal to 12s.
Scan, show that I'm plugging in. I'm plugging in when the s is what?
150.
Right? So this will be equal to what?
12 by 150, which is 1,800.
Everybody okay with that or no?
Yes, sir.
Okay.
All right. So we go back to we have ds over dt, and then we have dA over ds. Now we find dA over ds to be 1800. So just be a third by 1800, and that's 600.
And look at the
Now
units.
let's talk units. Area is centimeter square, and then time is in second. So centimeter square. No, time is in minutes.
Ah, that's
Yeah,
something
time is
people don't make mistake. Yeah, time is in minutes.
um centimeter square, well, per minute, or minutes minus one.
Now you don't have to say negative 600. Why? Because it's implied when you say
It's
Melton,
understood.
right? So you can say rate at which, just to be explicit, you can say rate at which surface area is melting. Paint in all caps.
That is negative.
You don't have to say negative. Like you can say rate at which surface area is melting, and that implies it's negative,
Right.
right?
I feel
And if
like
you
my teachers had to, take a little one mark away from a negative sign. So I might just have to put it in.
that's not a problem,
Yeah.
right? Or you could just say mathematically, but you will never say it's melting at minus 600 centimeters squared per minute. It
Right.
come like you're saying you're decelerating at minus 5 ms minus 2. That
Yeah,
makes
a
sense.
positive, negative, and accelerating.
Come like a double negative in English. Yeah, right? Cool. You okay with this?
Yes, sir.
Yeah, so this is why I think your teacher gonna bring this paper. Watch. Wait, Where will I be? This was an interesting question. Easy though. Yeah, like look at this.
Oh.
Well, I'll do the question in
Yeah,
here, so you can check it on YouTube.
yeah, I will.
And like look at this question. It was 5t minus 6 to the power half. If you had to integrate that,
Mhm.
you had to use the rule at.
Yeah.
Alright, Sheena, you ready?
I guess.
Alright. Paste, right? So we're gonna do the whole paper.
Oh, okay. We want to paper.
Well,
Okay.
as well as the others in class, of course.
Okay.
But primarily you and me and anybody else that wants to do it with me. Give me a moment. Mm, One moment. I just want to get this file on my iPad. Why does it not want to work? All right, cool. Well, people leave, boy. I see it's just Kamaya here. Cassidy, Sheena, Virginia, and Caleb. Who left, boy? Nathaniel, Kamaya, front left.
Yeah, so
Yeah.
you're just doing integration on that even coming for with us. So you probably just
Yeah. That makes sense. Mm, okay. 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 There we go. Where did I put that? Okay. I don't know if you want to tell them to join back because I feel like these are things that will be common in his exam. And who else was in class? Seeing 6 people. I was
no, but
originally
I guess let's be moving on to
we're gonna be doing okay. See all these topics over here. Essentially all these topics. So like log, search, differentiation. Well, we already do differentiation. Completely square indices, simultaneous equations, that kind of thing. Yeah.
okay.
Indices and thing.
Yeah.
Right. Okay. Right, so Sheena, you ready?
I guess.
All right. Hype. Let me go.
Mm.
All right. So Sheena, we give this one a read for now.
Divide 3x cubed minus 5x squared plus 4x minus 2 by 3x minus 2. I think it's 2 different questions, and she have it, so I'm not sure.
I feel so. I feel like a teacher make a mistake. That's fine. Well, let me tackle this, right? So one, well, I guess I call her 1A. I suppose I could call this B. So you have to do polynomial long division, right? So say
So, um, um, so Mrs. said we could do synthetic or long division, and I don't remember long division, but I remember synthetic.
I have a strong preference to
Oh, okay,
long division.
okay. I
But
don't remember it, but sure.
whichever one you're comfortable with. All right, so 3x minus 2, right? 3x cubed minus 5x squared plus 4x. All right, so the first question, what would I multiply by 3x to get back 3x cubed?
3x squared.
Nah, not 3x.
Mean 1x squared.
Right. So Sheena, first question, what by 3x will give me back 3x cubed? Sheena, what's x squared by 3x?
3x cubed.
Right, so I'll put 3x cubed here. Then we'll do x squared by minus 2. What will that be? Sheena, what's
Oh, sorry. Minus 2x. I mean, yeah, x squared.
right? Then I'm gonna minus. What is 3x squared? I mean, what's 3x cubed minus 3x cubed?
0.
0. What is minus 5x squared minus 2x squared?
Minus 7x squared.
Nah, gotta be careful. So you have minus
Oh,
5x squared here, and then you have minus 2x squared. So minus 1 minus, I'll turn up plus. What's minus 5x squared plus 2x squared?
Minus 3x squared.
Yeah, minus 3x squared. And then I'm gonna do what? Try to remember long division. What next?
You bring down the 4x.
Right? And then the whole process starts back again. So what would I multiply 3x by to get back minus 3x squared?
3x.
Nah, if I multiply 3x by 3x, I'll get 9x squared.
Oh, x, sorry.
Nah, I want to get minus 3x squared. So that wouldn't be positive x. That would be,
Negative.
right? What is negative x by 3x?
Negative 3x squared.
What is minus x by minus 2?
Minus 2x.
Nah, take your time. What's a negative by negative?
Positive 2x. Oh my
Right.
goodness.
Then we're gonna minus. What is minus 3x squared minus minus 3x squared? What's
0.
right? Once you minus in the same thing, I'll be 0. What is 4x? So you have 4x here minus 2x. What's 4x minus 2x?
2.
2x, right? What next?
You bring down your minus 2.
What next? But it can't really do anything. Yeah, you can't really do anything. So, uh, you could say plus okay, what would I have to multiply? What would I have to multiply 3x by to get 2x? That might be a hard question. But that would be 2 over 3. You know why or not? Alright, so Sheena, what would 3 by 2 thirds give you? What would 3 by 2 thirds give you?
2.
2. And I get back 2x. So if I multiply 3x by 2 over 3, what would I get back?
2x.
Yeah, I get back 2x. So that's why I put 2 over 3 here. So when I'm multiplying the 2 over 3 by everything here, the 2 over 3 by 3x is going to give me what?
2x.
Yeah, it's going to give me 2x. And then 2 thirds by minus 2 is what?
Um, 2 thirds by minus 2.
Yeah.
Minus 4 thirds.
Yeah, minus 4 over 3. Then you're going to minus, what is 2x minus 2x?
0.
And what is minus 2 minus minus 4 over 3?
I might have to check that just now. Minus 2 thirds.
Right, let me just verify it. So that'll be minus 2. And you gotta be careful, right? Minus minus 4 over 3. So that'll be plus 4 over 3. So you're gonna get minus 6 over 3. You said minus 2 thirds? Yeah.
So can we do the synthetic after? Because
You want to do it in synthetic?
yeah, when we done long division.
Okay, no problem. Right? I hardly ever do synthetic, so I'll try to remember how to do it. What's
Okay.
no problem. So over here, you can see that the remainder is what? What's the remainder?
Minus 2 thirds.
Right, so the remainder is minus 2 thirds. What is the quotient? So anybody know what
X
quotient is?
minus x plus 2 thirds.
Yeah. Right. Let me try synthetic. Try to remember that. How much of you guys do synthetic division as opposed to long division?
Honestly, I've never heard of it.
Yeah, like
Yeah, me too.
I so like I'm gonna try it. I'm just gonna try something. Just gonna try something. I don't really use synthetic division. So we have this cubic here, and we have this linear factor in the form 3x minus 2. Um, Probably divide through by 3. Yeah, I'm not really sure. We'll do synthetic
So you
division.
want to run it through how messy tree?
Sure, no problem. Talk to me.
So you write your little
Is you gonna write
I'm
the
thinking of,
coefficients?
okay,
You can,
yeah, you're removing a variable, so it will be 3 minus 5 plus 4 minus 2. And
mm-hmm.
then you draw a little, just, yeah, yeah. And then you find for x, so it will be 2/3
Right.
in what you divide it for. Yeah. And you bring down your 3, and then it's 2/3 by 3, and that going under your 5.
Over here.
Uh-huh.
So 2/3 by 3, that's 1. Right. And
Right.
then
And then
these 2.
yeah. So and then you multiply again by 2/3.
Right. And 2/3 by minus 4. That'll be minus 6. What was it? That'll be minus 8 over 3. Think. Yeah. And I suppose you add again.
Yeah.
That would be that'll be 12 over 3. So you're gonna put 4 over 3. Then what? You're gonna repeat the process again, so you're gonna multiply 2/3 by 4 over 3.
Yeah. Yeah.
You get 8 over 9. And then you add that and you put that down.
Uh-huh. Mm-hmm.
When you do, you're gonna get different results. So something is not right. Yeah.
I don't know, that's just how Missy well, she teaches also division as well, but synthetic just stick better.
So I just have a question about this method. Like, I know you say you don't understand and stuff, but like, she just said to divide by 2 over 3, but 2, how we just figure out that is 2 over 3 and then divide and we just
Because
skip another step.
So
the mhm.
Oh,
yeah,
okay.
yeah. But let me just verify this, right? Because something is wrong here. As so you're not getting the answer you're supposed to get. And I'm pretty sure this is the correct answer. Give me a second. Like, are the new kids using synthetic?
So my whole class is just synthetic.
Oh wow.
So I don't know.
Like the thing is, like in all my secondary life and in my time in university, I never had to do synthetic. It's interesting.
So I agree that something is wrong though, because when we did long study topic, we did both of them. Like Miss used to make us do both,
That's good. That's
and it
good.
was the same answer. So
Let me just verify this. Yeah, this is the correct answer. It's correct answer. Let me ask ChatGPT to to read out any mistakes here in synthetic. Um,
I just asking like to see if this might be a problem. I'm sure it's not, but when you're doing where you just showed me where you got 3x minus 2 and it's 2 over 3, and that is just for one x and these is x's to the different power.
wait, say that again?
The different powers. For 2x, 2 over 3 is for one of the x's. So when for 3 and negative 5, that would be for different x powers.
When you're writing it, we was told so the 3 would be 3x squared, and then the minus 4 would be minus 4x, and then positive 4 over 3.
But that still wouldn't be the answer because we first answer is x squared.
Yeah, I know something wrong, but that is just how we
Yeah.
did it.
Wait, so let me do back this thing. Right? So synthetic division, most likely it uses factor theorem, remainder factor theorem to work. So I'm trying to like engineer this. So if you guys recall, enter remainder theorem, you'd set the factor equal to 0 and you'd plug it in, and when you plug it in, that would tell you the remainder.
Yes, sir.
That's similar to what you're doing here, because you're saying 3x minus 2 is equal to 0, and then from what you're doing, you're finding for x, and you get in 2 over 3. That's what you're doing. So I'm gonna put 2 over 3 here, and then I would bring down the 3, right? Bring down the 3, and then I'd multiply 3 by 2/3. Yeah, 3 by 2/3, that's 2, right?
Yes, sir.
Right, and minus 5 plus 2, that's minus 3. And then I'll multiply minus 3 by 2/3, and that will give me minus 2. And then I'll add, so 4 minus 2, that's 2. And then I'll multiply 2 by 2/3, and that would be 4 over 3. And what's minus 2 plus 4 over 3? That should be
Minus
minus
2
2 over 3, right?
That's it.
Cool. Now, that means we do something wrong the first time we do it. Okay. So like, I think. So the only thing I could think of is you would possibly have to take this and divide this by 3, because if I divide this by 3, what will I get? Somebody tell me, if I divide that whole thing by 3, what would I get? Well, I get 1, and then what's
Minus.
3,
Oh, plus 2/3. The same quotient.
right?
Yeah.
And that would give you the answer. So you can't just do it. You have like some rules that apply here. So you're gonna end up with 1x squared minus 1x plus 2 over 3, and the remainder is minus 2 over 3. Yeah. I want to understand this method a bit better. Why is that happening?
But this is interesting because this is the first time that we have ever had to divide after we get an answer. Like, this is the first time synthetic has failed me.
The reason why that is because you have 3x minus 2 is equal to 0.
Mm-hmm.
It would work perfectly fine You know, if you have something like x plus 4, because the form that you learned is in the x, like, okay, you'll learn it in the form x minus k, I'm presuming. If you have something like x plus 4 or x minus 2 or something in the form x minus k or whatever, it should work normally. It should work just fine. But in this scenario, you had 3 by x minus 2.
Mm-hmm.
Let me explain.
No, I understand. I understand what you're saying.
No, let me explain. Let me explain, right? Let me explain, just to make sure nobody confused. Again, you would have learned it in the explicit form x minus k, where it's like x minus something, right? But this is not in that form. This is in the form ax minus k, you see now? Because, you know, you
Okay.
have 3x minus 2. So let me explain something. When you set this equal to 0, you're going to get 3x is equal to 2, and then x is equal to what? You're going to get what? Tell me we're going to get, you know? X is equal to what?
2 over minus 3.
Nah, 2 over 3.
Oh,
Yeah?
yeah, we divide them. Sorry.
Right, 2 over 3. Now, let me explain something. If you were to take 2 over 3 and you were to bring it across, right? You're going to get x minus 2 over 3 is equal to 0. But guys, I want you all to pay attention to something. Is this the original thing we had? Is that the original
No,
thing?
sir.
Tell me, Sheena, did we start off with x minus 2 over 3? What did we have at the start?
No, we didn't start.
What did we have at the start?
3x minus 2.
Good, 3x minus 2. So when you do synthetic division with 2 over 3, the result you get is not going to give you the original thing. Sheena, what would I have to do with x minus 2 over 3 to get back 3x minus 2? This is where I will click. What will I have to do? What will I have to do with x minus 2 to get back this? Anybody could figure it out? Or what do I have to do with x minus 2 over 3 to get 3x minus 2?
Multiply by 3.
Yeah, you'd have to multiply by 3 throughout. And that's why in the final answer you have to do the opposite, which is to divide by 3. It's interesting. Because like, yeah, this is interesting. Because Shayna, look at this, right? When you move across the 2 over 3, you're gonna get x minus 2 thirds, but did you start off with that?
No, sir.
No, it didn't start off with that. And so if you wanted to get back 3x minus 2, you'd actually have to multiply by 3. But to figure out where it was going to plug in, you actually had to do what? Like, okay, how did we get 2 over 3? How did we get 2 over 3? At some point, we did what? We divided by what?
3.
Yeah, we divided by 3. And that's why I suspect that's happening. Just to make sure this is not a one-off occurrence, would you like to do another one similar to this?
Sure.
Okay, no problem. Let me ask ChatGPT to give me a cubic. Actually, I'll make up my own cubic. X plus 3 by 2x plus 2. Alright, so I'll make up a cubic here. Let's just say we had 2x cubed plus 10x squared plus 14x plus 6. And let's just say I want you to test. Actually, wait. So Virginia, you never learned synthetic before.
No, sir, it's new to me.
Low-key
All
new.
we've done, yeah, all we've done was polynomial division factor and remainder theorem, and that's about it for like polynomial division.
See,
Yeah.
all right. So Sheena, let's just say we had this cubic, right? And I want you to divide that by 2x plus 4. You ready? So here what? First things first, I'm going to do polynomial long division. I trust that the most. That's guaranteed. It will work. All right? That will work for sure, 100%. Shana, you all right?
Yes, sir.
Like real quiet, real quiet.
No, fine.
Right, so Sheena, let's do this fast, right? What I multiply by 2x to get back 2x cubed.
X squared.
X squared, right? Then I multiply x squared by 2x, that'll give me back 2x cubed. Then x squared by 4, that'll give me 4x squared. Then I'm going to minus 0. Then I would say 12x squared minus 4x squared. What would I get? What is 12 minus 4?
Oh, sorry, 8.
That'll be 8x squared. Bring down the 22x. Then I ask myself, what by 2x will give me back 8x squared? What by 2x will give me back 8x squared? So what by 2 would give me 8? What by 2 would give me 8?
So 4x.
Right? Yeah. And I would have to get the x to multiply by the x to give me x squared, right? Then I'm going to multiply the 4x by 2x. That'll be 8x squared. And then I'm going to say 4x by 4. What's 4x by 4?
And 16x.
Right? Then I minus 8x squared minus 8x squared is 0. What is 22x minus 18x? Minus 16x.
6x. I mean
Right?
6.
6. Nah. Oh, yeah. What's in, right? 6x. And I'm going to bring down the 12 now. Gonna bring down the 12. Plus 12. What next?
You're gonna see what you're multiplying by 2x to give you 6x.
What that will be?
3.
Right? And you get 6x. And you get plus 12. Bam. Minus. You get 0, 0. So guys, since I get a remainder as 0, it actually tells us that 2x plus 4 is our what of this function. Is our what? It's a factor, right? So cool. Your quotient is x squared plus 4x plus 3 and your remainder is 0. Let's try synthetic division now. And let's see what happens. So the coefficients are 2, 12, 22, and 12. And I have 2x plus 4, right? I'm going to find what x is setting it equal to 0. 2x is equal to negative 4. I divide both sides by 2. So x would be equal to negative 2. Shin, are you okay with that so far?
Yes, sir.
All right, so I put a negative 2 over here. First step, I bring down the 2. Then we multiply 2 by negative 2. That'll be negative 4. Add that. 12 minus 4 is 8. Right? Then I say 8 by minus 2 is minus 16. Then 22 plus minus 16 is like 6. Right? And you multiply 6 by minus 2, that's minus 12. And 12 minus 12 is 0. Now, Shina, are you there?
Yes, sir.
Remember at some point, and I think those of you guys that like hard maths would see what I'm talking about. You remember I mentioned remainder theorem a little while ago? Remainder theorem. I don't know
Yes,
if you
sir.
realize this right, but the values you get in here is actually what? Like 2, 8, 6. I'm not sure if I see that. That's what you get in. It's actually remainder theorem you're using in synthetic
Oh,
division. That's what you're doing. And so, as you'll see, Shana, when you work this out, and if you didn't know any better, you'd have said 2x squared plus 8x plus 6 and go about
Mm-hmm.
today, right?
Mm-hmm.
But that's not true.
Yeah, divide by 2.
I have to divide by 2. But you know why I have to divide by 2? Look at this process. What did we divide by at some point?
2.
We divided by?
2.
So if you divide by 2 there, you'd have to divide by 2 here. And you'll get 1, 4, 3, which is what we get there. So the reason why you never had to do this before is because the ones you would have done would have been like x plus 3 or x plus 1. But this is the first time you're probably dealing with one in this form. Yeah. Shin, are you okay with that?
Yes, I understand.
All right. I see Virginia has her hands up. Virginia, talk to me.
do you just divide by the coefficients of the first term?
Yeah,
Because in the other question it was 3, this one is 2.
I believe so. But let me confirm that though.
Okay.
Let me confirm that. But I think you have merits in what you're saying.
Yeah, that was the
Because
pattern I saw thus far.
because if you factorize this, right? If you factorize a cubic, you'll have 3 linear factors. One of the linear factors should have 2x in it, and the other linear factors would have x and x. That would give you back 2x cubed. But let me just verify.
Okay.
Not quite. Nah.
Oh, this was just a coincidence.
Because when I was explaining the example to you with the linear factors, in this case it's 2, right? 2 is a prime number, but like what if you had 14x cubed, then you could have an instance where it's like 2x here and it's 7x over here. Don't make
Oh, I
sense.
see. Oh, yeah.
The rule here is that, so you see how we had 2x plus 4 is equal to 0?
Yes, sir.
When I moved across the 4 and I got 2x is equal to negative 4, what did I end up dividing throughout by?
2.
Right. So if I divide it throughout by 2 there, I'll do the same thing. I'll do the same thing here.
Okay.
In this example, we had, didn't write it, but let me write it over here. So it was 3x minus 2. So 3x minus 2 is equal to 0. I'll move across the minus 2, and that minus 2 will turn to what?
Plus 2.
But at some point, I'll have to do what? What will I have to do at some point?
Divide by 3.
So that means when I get my final answer, I'll have to divide by 3 as well. Well, I should say my second to last answer.
But like, wouldn't you still be dividing by the first term? But like in this case, it would be the dividend, not the quotient.
Correct, but it doesn't, I can't generalize it because it will break in some instances.
Oh, okay.
Like, it was just coincidental that this worked here, but it wouldn't be the case throughout.
All right.
Like,
Well,
let me see
that's good to know.
let me see if I can give you a case where that would not be true. Right?
Okay.
Sheena, you okay with this? Right?
Yes, I understand.
It's a good thing we do this, boy. Cause like, who knows what'll happen if you do synthetic division and you was dealing with a case like this. Things would not go well.
But synthetic too, you probably
Say that again?
but I say one misses to synthetic too, so um
My concern is that she didn't pick up on this. But I sure she did. I hope so. For the sake of you all. And you say you never see this before.
I probably have seen it and probably did not divide. But no, I never have divided after synthetic. And I never get wrong either. So I don't know.
Right.
But
That's
yeah.
suspicious. That's very suspicious. Let me do one more question. It's one more question, right? But you wanna do this question, Mama?
Sure.
And let's just say I want you to divide this by 7x plus 1. So
All right.
as you can see, let me show you something, right? Let's stick with the question. So the first thing, I'll put this equal to 0, and then I'll do what?
Find the value of x.
Right?
Well, bring the 1 and divide by things. So it'll be negative 1/7.
So I divided throughout by
7.
whole lot what?
Yeah.
And so when we're doing synthetic division, we'll say 14, 72, 94, and 12 minus 1 over 7. So we're going to bring down the 14 and then do what?
Are we dividing by 7?
Now we're gonna multiply this by minus 1 over 7. If I multiply 14 by minus 1 over 7, what would I get?
Minus 2.
Minus 2. Then I add 72 and minus 2. What would I get?
That would be 70.
Right? And I'm gonna repeat the same process. I'll multiply 70 by minus 1 over 7. What would I get?
Would that be minus 10?
Right? And then I add 94 and minus 10. What would I get?
84.
I'll repeat the same process again. Minus 1 over 7 by 84 is?
I'm gonna have to use my calculator in my brain. Okay, minus 2.
Why you feel like you got a one? And then we're
I
gonna say
don't
12.
know.
12 plus minus 12 is?
0.
Right. No. Virginia. Sheena, if I didn't know
Yeah.
any better, okay, would I say that this is the answer, hence?
Well, not as I know better, no.
Sheena, would you have just said that this is the answer? Be honest.
Previously, probably.
So, but here what? When he was doing the working, we actually divided by what? What did we divide by?
7.
7. So what do you think I should divide throughout by over here?
7.
So what my answer be?
2, 10, 12.
Yeah, that's the actual answer. So you see, your generalization was wrong. Because like if
Yeah.
in an instance you don't have a prime coefficient for x cube, it won't work. The reason why you was thinking that is because in the previous examples, the numbers I used were like prime numbers like 2 and 3. But like if I use something like 14, I will like imagine this, right? If I use something like 14 and I factorize it, I would have something like x plus 3 by 2x plus 4 by 7x plus 1. I would have
Alright.
I would have instances where I might divide 1 by 7, I might divide the other one by 2. So it depends.
Yeah, I see that now. It was just a coincidence that misled me.
That's why mathematicians must be so careful before they come out and say something is true.
Oh,
Just because you see something working all the way up to the 100th time, that don't mean the 101st one gonna work. Yeah.
is that? But like, would that kind of intertwine with physics, like how they thought the caloric theory was real until this other guy came out,
Yeah, that's exactly the case.
Okay.
Right?
My
Now she,
sister,
yeah, come on, I talk to her.
when Virginia was saying divide by the coefficient, did she mean of the polynomial or
The
the
polynomial.
divisor? Because oh, okay, well,
Yeah.
all right.
Right, so Shina, that's what we get in there, right? And Shina, I worry that you don't believe me. I worry that
I believe you.
like I
Okay,
concerned
no.
because like this is the mathematically correct thing. I know some of you all like okay, I will admit when I'm wrong and when I don't know something, but I know I'm not saying that's you, right? But some people have a hard time breaking away from things. And I'm not sure that you think that this wrong because of what you learn in school. Not saying any teacher
No,
necessarily teaching you wrong stuff, but like I just concerned. But this is the correct
no,
thing. This
I
is the correct thing.
understand. Yeah. It's a stubborn, man, not a stubborn.
All right. And just to make sure, you know what we're gonna do? We're gonna do polynomial long division and see if we get the answer. Let's see. Right? So we're gonna divide by 7x plus 1. And so you tell me what to do.
We're gonna see we need to multiply by 7x to get 14x cubed.
Nah, not 7. 7 by what is
Sorry?
7 by you said 7 by 7, that'll be 49. It should be
No,
7.
I said you have to see what you have to multiply
Oh,
by 7 to get 14x.
oh yes. And what would that be?
2x squared.
No, I want you all to realize something, right? I want you all to make a connection between this and synthetic division. Shina, aren't I just dividing 14 by 7 and I get 2?
Yes, sir.
I want to draw your attention to something. Isn't that what we did over here?
Yes, sir.
Let's stay with me, right? I want you to connect the dots. What we're gonna do next,
We're gonna multiply the 2x squared by 7x plus 1.
all right? That'll be 14x cubed, then what?
Positive 2x squared.
Right? It cannot be mind blowing, right? So this can't be 0. Away is 72 minus 2.
17.
Now here what, right? Then we're gonna ask ourselves, or what I have to divide this by. Okay, what I'm trying to say is to figure out what you put here, you would divide this by what? What would I divide 70x squared by,
7.
By 7.
7.
Yeah, by 7. And I'll get
10x.
Virginia, you see what I'm saying? Check this right, Virginia. At the
Yes.
start, to get 2, we said 14 over 2, right? What's saying? 14 over 7, right? I said 14 over 7, yeah?
Yes, sir.
If you see something, that's what we did over here, 14 over 7 to get 2.
Yeah, I realized we're getting back the same numbers throughout. I just finished it.
And like if you notice here, 72 minus 2 is 70, and then of course we're gonna divide by 7 here to get the quotient. So synthetic division is just a shortcut of polynomial long division, and you're using the remainders, but in the end you have okay, I want you to draw the connection between this and this, right? To get the actual answer, you have to divide by the 7. Yeah.
Yeah.
But even this is a poor generalization because, Virginia, imagine if you had 7x plus 3, right? It'd have been more complicated. You can't just say 7x plus 3.
Oh.
The point is, if you have something in the form ax plus b is equal to 0,
Yeah.
whatever, actually, never mind, it would work. The point is, Virginia, you see this number here? You see that 7? You see the number in front of the x?
Yes, sir.
That's where you had to divide by. So if I had something like 9x plus 3, I would have to divide by what?
9.
If I had something like 2x plus 8, I would divide by
2.
cool. You understand it? Nice.
Yeah. So
Then
my
we can-
theory was because I mean you still have to divide by the first term, but like of the dividend instead. But not in all cases. I don't know. I don't know.
Yes. You had to divide
Yeah.
the first term by the dividend,
Okay.
right?
But what if we take the x squared term? Would that still apply?
Yeah, what's that apply? Because
Oh,
I think you mean like over here or
yeah.
not?
Like if the dividend was like something x squared plus x plus c.
Or like if it was like x squared, ax squared plus bx plus c or not?
Yeah, as a dividend. Yeah, as a dividend.
Yeah, it would work.
It would work? Okay.
Then shit, now we would bring down the 94x. And what to do next? Tell me, Sheena.
You see, and what you have to multiply by to get 70x squared, which will be 10x,
Mm-hmm.
and then you multiply your 10x by 7x plus 1.
Right.
Right.
But I see why you pick synthetic though. Having done synthetic now, I see why you pick it. For sure. For sure.
Yeah.
Right? I just never did synthetic. I been real with you, I never do synthetic. I never had a
So
use to.
I think it's because when we start art maths in school, this was the first topic we did. So synthetic was just easier to remember.
I understand. But you have to remember that they have like always one rule in synthetic, right? If
Yeah.
you had to divide. Over here, 94 minus 10, that is 84x. What next?
You bring down your 12.
And of course, you'd have to
Mm,
84 over,
7,
right? And that'll give you what over here,
12.
right? Cool. The both methods give us the same answer now,
Yes, sir.
right?
Yes,
So
sir.
we're okay with polynomial long division and synthetic.
Definitely.
Come on, are you okay? Or not?
Yes, sir. I'm good.
I didn't hear Caleb in a long time. Yeah, I didn't hear Caleb in a long time. I wonder if Caleb is okay.
Yes, sir.
Caleb, we will do a question just now. Don't worry. Yeah. All right, so we should be okay with those types of questions. Now, Shayna, read part B for me. Wait, give me a second. Shayna, you're not gonna get a break. Trust.
Oh, really? Okay.
I gotta make sure you do good
Mm,
for your own benefits. Shayna was like a day one and all there. Like when I started this Form 4 lessons, like at Form 4 level, she was like one of the first students. Can't forget Shayna. Yeah. Although she don't talk anything in class, but she's a OG, you know?
sometimes.
Yeah. No
She's
shade
the
thrown. No shade thrown.
Mm.
Yeah, Shayna, get that question I read from her.
The expression f of x equals x cubed plus ax squared plus bx minus 12 is divisible by x minus 2 and leaves a remainder minus a t when divided by x plus 1. Find the values of the constant a and b and the other linear factors of f of x.
Now here what, I know all gonna see the word divisible and all gonna try a thing with polynomial long division and thing. I know all gonna do that. Some all gonna try to divide and all kind of madness. No, not gonna do that. What I want you all to immediately see when you look at this, Shayna, when you look at that, how much unknowns you seeing?
2.
And as a matter of
Well,
fact, it reiterate that here in part one, right? They say A and B. So you're trying to find for how much unknowns, guys.
2.
2.
I hear from Cassidy in a long time, but Cassidy, anytime the way to
Correct.
find two unknowns, you really have to do what? Two unknowns. What?
Abstract.
Nah. Anytime I hear two unknowns, What should
Not
your
simultaneous.
yes?
Equations.
Anytime
Yeah.
you see two unknowns pop up, Caleb, anytime you see two unknowns, yeah, you're dealing with simultaneous equations. And to solve a simultaneous equation with two unknown, you need how much equations?
2.
Generally speaking, if you have n unknowns, you need n system of equations. So like if you had 5 unknowns, you need 5 equations, right? If you have 2 unknowns, you need 2 equations. So Shina, like I just said, you have 2 unknowns, so you need to form what? What do you need to form?
2 equations.
How are we gonna form those equations? By dividing or what we gonna do? You tell me.
You're gonna so you're gonna use the x minus 2, so it will be x is equal to 2, so you're gonna plug it into f of x. So it'll be f of x. F of 2 is equal to 2 cubed plus a 2 squared plus b by 2 minus 12 equals 0.
Now here what? Why you telling me equal to 0? There's a reason why you're telling me is equal to 0. Why? How you know is equal to 0? How you know that?
So let's say is divisible by x minus 2 and do have
Good.
remainder.
Good. Guys, if you hear something that if you hear something is divisible, will it leave a remainder?
No, because it's a factor.
Right. No remainder. So Caleb, if something is divisible, the remainder will be what?
Zero.
Exactly. Right? Cool. So for the first part, I set it equal to 0 because they told me it said divisible by x minus 2. And that tells me that the remainder is equal to 0. Are we okay with that?
Yes, sir.
All right, let's simplify this and form a proper equation. What's 2 cubed?
8.
8, right? 2 to the power 2, that's 4. That'll be 4a plus 2b minus 12 is equal to 0. Caleb, help me simplify that. Caleb, you see any like terms there?
8 and 12, sir.
8 and minus 12. What is 8 minus 12?
Minus 4.
Right? Caleb, you want to leave it like this or what do you want to do? Talk to me. It's one equation.
Uh, 4a plus 2b equals 4.
I like what you're thinking. That's good. Anybody could tell me why Caleb thinking like this? He's setting it
Because
up
we
to,
should form his first equation.
right? But he's setting it up to do what? Anytime you set it up like this, you're setting it up to do what? What are you trying to do?
So,
The elimination method.
Elimination method, right? That's like a goal. Now the other piece of information, Shina, is it's telling me that it leaves a remainder of minus 30 when it's divided by x plus 1. So what we're gonna do there, Shina?
You're gonna do the same thing we now do, but for minus 1. But so for equation 1, we could divide by 2.
Yeah, if you want to get divide by 2 to simplify, that's not a problem. You want to do that?
Sure.
You're gonna end up with 2a plus b is equal to 2. Caleb, you okay with that, right?
Yes, sir.
All right, let's do the other one real fast. So that is x plus 1 is equal to 0. Um, so that'll be f of minus 1. So that'll be minus 1 cubed. Come on, I feel like next class I'll call on Tani more. I feel like he did again horrors.
Um,
Yeah, call on them.
so he
Call on.
just there.
I see.
And he thought I'd come and film now, so That is why he had to leave now, but earlier, yeah.
I will call on them more often. I don't want anybody to feel left out. I feel like I was forgetting the boys. Nah, I'm Caleb on the
Yes,
time.
yes, always forget the voice. There's just there.
No, it's like ask Cassidy is like usually be the reverse.
Yeah, yeah.
Be the reverse.
Oh, okay.
Yeah,
You know, he has his two sons
Yeah,
his friends.
very well.
yeah. And there's always be talking about Nikolai and Romano and then eventually
Romano.
Aiden. Yeah. All right. And we're gonna set this entire thing equal to what? What was your remainder?
Minus T.
Let's move with this. -1 cubed and -1. -1 squared, that's +1. So that'll just be 1a. Plus b or -1 then minus b. Yeah, -12 is equal to -2t. Caleb, help me simplify this.
-1 minus 12. Well, a minus b minus 13 equals -30.
Right? Caleb, sorry, boy. Sorry. I'll call you more.
So this is my public request to get a break after these two parts.
Yeah.
Yeah, I
Okay.
need to go and look for my glasses. My eyes starting to.
You don't have your glasses?
No, it's somewhere in my room. But my eyes starting to hurt now because I'm watching the screen.
No
So,
problem. No problem.
so after these two, yeah.
I'll give everybody a break, right? My Apple Pencil out of charge too. Right. Israel PS boy, plenty questions. Oof. But I say,
We actually doing all of that.
yeah,
Oh,
all again,
okay.
all again is, I don't know, it's come like free in a sense, because, I promise all 2 hours, but it's like, you know,
Yeah, about 16.
yeah, as we willing to over and beyond for all, I'll just add a penny effort and I'll help all you. That's the thing. Once I'll here, I helping all,
Yes, sir, I'm always here.
Yeah, we got Virginia one time and appreciate that. Once I'll here,
I'd be oh, that's my bedtime wasn't 10 o'clock.
I understand. You just prioritize your sleep. I can't blame you.
I don't choose to.
Oh,
Father.
oh.
Gosh, I want to be more like Kamaya.
Well,
Why?
tell
We
it
gotta
that.
go in
I
with
just
Well, I feel this is a valid excuse, right? Because you're grinding work on tomorrow is Saturday. So it's not like you have anything to do Saturday. Unless I'm making
Right.
yes, you do, and the term is starting for me next week. So
but we grinding,
But
so
guys, my bedtime on the weekday is 9 o'clock, and the bedtime on the weekend is 10 o'clock. So going over is like, you know.
your, your,
Anyways, I
parents-
still going on and do it.
your parents is on a strict program.
Yeah.
I see. I see. But Caleb, when I move across the -13 and I add it to -30, what I'll get? Caleb,
Yes, sir.
what I'll get? When I move across our -13.
Oh, hold on now.
If all I want, I could always do a live tomorrow going through like the rest of the paper.
-17.
Yes,
so yeah.
because I
Do
have
the
lessons
live
tomorrow.
Tuesday or something.
Monday,
Yeah,
I
like
free. Monday, I
Monday,
free.
yeah, that good.
Monday,
like
I free.
Tuesday night.
But I
No,
know
Wait,
all your
no,
exam.
my exam is Tuesday.
my
exam
exam
My exam is Wednesday.
is Tuesday.
Wait, so
So
we're not finished
Monday
now?
for sure. Monday looking like the
No,
Monday,
normal.
but
Monday.
Cassidy have she exam. Now I have
No,
plans.
my exam is Tuesday.
Okay, well, I
Yeah.
feel on Sunday. I feel like a Sunday,
And
but like
my
Monday.
chem exam
What
is
time?
Monday.
No, no, not Monday. Sunday looking like a.
Okay,
Sunday.
but wait, Sunday, what time?
I don't want to go in the morning or in the evening.
So I have church.
In the evening, because I have church.
Oh, okay. Or like 5 to whatever, or like 4 to whatever.
Yeah, yeah.
Okay. Well, let me
That's
continue
easy.
this first. Minus 30 plus 13. That is minus 17, and
Yes,
Yes,
sir.
sir.
alright, so we have two equations. What do you think we should do? Substitution or
Um,
elimination? What do you want to do?
Elimination.
Elimination.
I agree. Now remember, if you have the same coefficients, you do what? Yeah, the same coefficients, you minus.
Subtract.
And if you have opposite coefficients, you do what?
Add.
Right. We had the same or opposite here?
Same.
No, we don't have the same. I see in two here and I see in one here. It's not the same.
Wait, it's not based on the signs?
Nah, it's based on the coefficient and the signs. So
Oh, okay.
over here, because think about it, right? If I want to eliminate an unknown, and if I have 2a and 2n's, I can just take it away and I get 0a.
Yes,
Yes.
sir.
So it's dependent on the coefficient. So I wouldn't try to get rid of this. Let's look at this though. Is it the same or opposites?
Opposite sign, same coefficient.
Opposite, same coefficient. So what do you think I should do there? Add or subtract?
Yes, sir.
Add.
I should add. Alright, where's 2a plus a?
3A.
2,
What is plus b plus minus b?
0.
And what is 2 plus minus 17?
Minus 15.
Alright, the answer is within reach, guys. 3a is equal to minus 15. What to do?
Divide by 3.
Minus divide by 3.
So a is equal to what?
Minus 5.
Minus
Minus 5.
Caleb, I find like you really improved though. I must commend you on that. Big up yourself. Caleb, like you doing work on outside of like class or because it sounds like you're doing that or not?
Sometimes, yes, sir.
Yeah, sounding like you're improving. Caleb, how am I gonna find? Okay, let me not say anything. Caleb, what would I find for next? I'll have A. What to do next?
Find to be
What do you want to use to find for B?
use the second.
Does it matter
Yeah,
which?
we could use the second one.
Does it matter which one we
Nah,
select?
it doesn't.
Don't matter. Alright, well, let me use
Nah.
the second one. So A minus B is equal to minus 17. What am I gonna do? No, guys. I want to find for B. What am I gonna do next?
So, you substitute
A into
minus
B.
5.
Alright, so A is minus 5. So minus 5 minus B is equal to minus 17. What next?
Bring across the minus 5.
Alright, bring across the minus 5. So Caleb, I move across our minus 5. What happened?
We're going to turn to positive 5. So minus 17 plus 5.
Right, so minus B.
And minus 12.
So B is equal to?
12.
Yep. Badness, badness. So here what? We had done, eh? Well, I mean, in this case we done, right? A and B. A is minus 5 and B is 12. Now, a lot of you guys are going to forget the significance of this, right? And I just going to be confusing the next question. I know that. Because in the next question, they wait to find the other linear factors of f of x. Anybody want to tell me what you think you might have to do for the second part?
Divide.
You tell me what to do.
Wait,
We could divide, yeah. But am I going to divide x cubed plus ax squared plus
no,
bx?
yeah, substituting A and B first.
Oh, all you hear that, right? You didn't just find A and B for nothing. That be for a reason. In part 2, you have to substitute A and B. And then I'll divide by what? Will I divide by x plus 1?
No,
Why wouldn't I divide by x plus 1? Tell me.
because it's not a factor.
It's not a factor, right? Are we doing that? Will we divide by x minus 2? I like this question. It's a nice question. So part 2. We're gonna write what f of x is the full thing. So f of x is gonna be x cubed plus what?
So x cubed plus minus 5
So I could just say
x
minus
squared.
5x squared.
Yeah. Plus 12x minus 12.
Can I make it look like I didn't trust it if I have it? Sorry. I went and looked back. Cool. So that's f of x. And Kamaya, do you know why we're gonna divide that by x plus 1 as opposed to what I was saying? Kamaya, what would I divide this by to find the other linear factors? X plus 1 or x minus 2?
X minus 2.
Why had to do x minus 2?
Because x minus 2 is a factor. Because
Good.
it equals this.
So the quotient will be a product of two other linear factors and the remainder will be 0. Cool. So of course I'm gonna pick x minus 2. Or they want to do synthetic or what do they want to do?
Long division.
Polynomial, long division.
Okay, boy.
Synthetic.
Let me try synthetic now. I'll give it a chance. So if I use in synthetic, I would put this equal to 0 and x would be equal to what?
2.
2. Did I divide by anything there?
No, sir.
Nah. So in our final answer, we won't have to divide. Right? So x is equal to 2. So I'm gonna put the 2 over here. And I'm gonna write the coefficients of the term. So this is what x cubed. What that is.
1.
1,
Then we have minus 5. What we have next?
Positive 12.
12,
Minus 12.
Right, so we're gonna bring down the 1. What next?
2 times 1.
You know it already. I'm gonna ask somebody else. Virginia. Wait, I know Virginia knew it. I feel like Virginia knew it. Let me ask Cassidy. I didn't hear Cassidy in a long time. Cassidy, you ever do synthetic division?
No, sir.
Or-
And I feel like even though you explain it, if I learn this vision, I'm gonna forget how to do regular polynomial division.
Okay, no problem. Well, let me ask Kamaya. Kamaya, you remember how synthetic division was going now?
Yeah, I think so.
So I dropped only 1, what am I gonna do next?
Multiply 2 by 1.
And I'll get 2. What am I gonna do with the 2 and the minus 5?
You're gonna. I don't know if it's minus or plus.
Plus. What is minus
Okay.
5 plus 2?
Minus 3.
What am I gonna do with the minus 3?
Yeah, multiply by 2, so it'll be minus 6.
Right?
And then you'll plus that and you will get 6.
Then
And you
what?
multiply 6 by 2, which would be 12. And you plus that and you'll get 0.
Correct. Bingo. So you're gonna get,
Yes. And we do have to divide by anything because
we didn't divide by
Yeah.
anything here.
Yeah.
Right? Good. Come on, are you sure you do better than maths? I feel like you do good in it.
half of paper was blank. I think I did bad. I don't know, sir. I think I did bad.
You don't find Kamaya that sounds smart. Find Kamaya that sounds smart.
Yeah. Intellectual
So,
level of understanding.
Yeah. It's
y'all
like,
have the wrong idea.
do we do?
Either just be going along and whenever others just try and
I can say everybody here smart. Caleb, Sheena, Cassidy, Kamaya, Virginia, everybody's smart. Nathaniel. Pretty good.
Yeah, so I know I was saying I'm saying leaving on the tunnel because he leave.
Nah, I will talk to him after class. I'll tell him I didn't forget him one thing, you know. Next class I'll talk to
All
him.
right. Okay.
I know what it's like to be forgotten. I don't want anybody to feel like that. So
So you okay?
nice pass from her, nice pass from her, nice pass from her.
All right. So we won't bring it back up.
I find like some good friends I just remember man thing. You know, that was
All
only
right.
pass. That was only pass. Yeah.
That's good.
Right. So your answer here is just going to be what? What would it be?
1x squared minus 3x. Perfect.
Yeah. And that would be the quotient, right? But they want us to find the other linear factors. But this is a quadratic, so what will I have to do with the quadratic?
Figuring factors.
Ah,
I'd have to
okay.
factorize. So to get x squared, I'd say x by x. You know, each bracket should have an x in it. And then I'm looking at the last number. Last number is 6. We're looking for two numbers. I would multiply to give them a 6 and add to give them a minus 3.
So
And
the
I see
factor
that.
is what?
Did they make a mistake here?
Mm,
Well, I'm not sure.
Well, here what? I don't trust synthetic division. Let me try it with like the other, like polynomial long division and see what happens.
okay.
Right? Let me just run through back my working, make sure everything is legal. Anybody want to tell me how I could check to see if A and B correct? Do they know how it is go?
Plug it into one of the
Yeah.
equations and see if you get back the minus 17 or the other thing.
Correct. So minus 5, minus 12 here, that's minus 17. And then 2 by minus 5 is minus 10. Minus 10 plus 12, yeah, that's 2. Yeah, that's correct. I'm gonna do, and did I plug it in correctly? So it was plus ax squared, so that'll be minus 5x squared plus bx plus 12x minus 12. Yeah, I do trust synthetic. Let me try it. Long division. I'll see what happens.
So,
Right.
you know, this used to be my nemesis until I saw Math Vibes.
That's good. I find like it glazes on too much though.
Oh, like, I'm serious.
And the
It
glazes.
really. No, I used to like AdMaths and I detested it. Now I'm starting to like it again. I don't know. I don't know what's happening.
Until you know how like when your mama get your parents will be like, what you want? You know what I'm talking about?
Nah.
Yes,
Yes,
Okay, not fine.
yes.
Like not fine.
Nah.
All right. But
All seriousness, I used to hate this polynomial division.
don't worry, me too. It take me so long to learn polynomial long division in general. So I understand the
Yeah.
feeling. So to get x cubed, I would say x squared. X squared by x is x cubed. All right, then Scrappy boy, you go. X squared by minus 2 is minus 2x squared. I mean minus 5x squared minus 2x squared, that'll be minus 3x squared. Drop down this, that'll be plus 12. Up a minus 3x here, that'll be minus 3x squared plus 6x. So if I look in like the synthetic was correct, maybe there's a mistake in the question.
Maybe it was a trick question for you to say none.
Because you wouldn't get any other linear factors. That would just imply to have one linear factor and two quadratic factors. This could be 0. This could be minus 6x. Drop down to minus 12. Then that would be minus 6. And that's the answer we get for synthetic.
Yeah.
Yes. So you didn't trust the synthetic division.
Wait. Something sus is
Yes.
happening.
I,
Something
I,
sus is happening. Are you seeing me? Watch
because
this.
you will get 0 2 times.
No, what?
Wait, no.
I would
You will
get
get
plus 12 over here. and I'll get minus 24.
Yeah.
Oh,
Something ain't right. So let's come on a second. Come on a second. Something is on. Something is on. Human errors, eh? Tell it, human errors. Let me ask the AI overloads to just give me the correct answer. But like, I mean, I wonder will make the mistake though. You know what? I'm not using it. This is really easy. It's an easy question. We shouldn't be making any mistakes. So let me run through back our arithmetic. So we had x cubed plus ax squared plus bx minus 12. If it is divisible by x minus 2, the remainder is 0. So I'm going to plug in 2 into that. So that'll be 2 cubed is 8. That'll be 4a squared plus 2b minus 12 is equal to 0. 8 minus 12. 8 minus 12 is minus 4 more across, so I get 4. So 4a plus 2b is equal to 4, right? Divide that by 2. 2a plus b is equal to 2. Then minus 30. So x is equal to negative 1. That'll be negative 1, negative 1. That'll be. Oh, wait. No, that's correct. That's correct. Minus 1 squared is positive. So positive a minus b minus 12 is minus 30. That's minus 13. Are they sure minus 30 plus 13 is minus 17?
Yes, sir.
So where did make a mistake? I don't see any mistakes. Did we make a mistake here? It's real suspect. It's an easy question. Just very sus. Uh, but like when we do the synthetic, we see is 0. So like what happened here, boy? Is it that we can't trust polynomial long division anymore?
Guys, please don't tell me that.
Yeah, this is a trick question. ChatGPT confirmed that this is the answer. You can break it up into a linear factor. Yeah. Sus question. I wonder why this not working now. I want a volunteer to run like do back this one. Any volunteers?
Yes, sir.
Thank you, Caleb. So Caleb, what's the first step?
X cube. How do we go into x? It could be x squared.
Right? Then I'm gonna do over the x squared.
X squared by x is x cubed. And x squared by minus 2 is minus 2x squared. Minus 5x squared minus 2x squared is minus 3x squared. And then you're bringing down the 12, so you're going to be plus 12x. And 3x squared had to go into the x. You're going to be 3x minus 3x. And minus 3x by x minus 3x squared minus 3x by 2 minus 6.
Take your time.
Right. Oh, minus 6x plus, yeah.
I think that's the mistake we made last time, I think last time we had minus 6 for some weird reason.
Yeah.
different.
And 12x minus 6x.
Minus, yeah.
Nah, that'd be positive 6x.
Nah, what the minus stuff I was talking about.
Oh. And then what next?
6x into x is plus 6. And 6 by minus 2 is minus 12.
I thank God. Okay. I'm converted. Shima. I'm converted. Converted. Yeah.
Very
Yeah.
nice.
Happy? Yeah, synthetic is a lot easier. It's a lot easier, to be honest, and all of this.
So
But
just to confirm with the
Yeah, I'm so
synthetic,
glad that I
adding.
have.
say that again?
For the synthetic, you're adding, not
Yeah,
subtracting.
yeah, then
Okay.
So I'm so glad to have changed your view on synthetic division.
yeah. This is the thing, eh? I don't want to let it ever be like too like stubborn. You know, if you find a better way and it is literally a better way, why you still doing the hard way? You know what I mean? Life is about viewing things objectively. If something easier, just do it. Don't study what anybody's saying or like how stubborn it was, just do it. I find the synthetic thing a lot easier, low key. But let me just explain a couple things, right? They said in the question to find the other linear factors of f of x, right? That's what they said. Now, truth be told, f of x could be written as x minus 2 by what? Does anybody know? F of x, the function, could be written as what?
By x squared minus 3x plus 6.
Good. And here's the part where you would try to factorize this. But you would say x squared minus 3x plus 6 cannot be factorized. Actually, that's going to give you imaginary solutions, right? If you find the discriminant, you'll see you're going to get a negative answer. So x squared minus 3x plus 6 cannot be factorized. Therefore, what would I say?
There are no other linear factors.
Yep. The statement is important, so that if you truly understand it. And if you want to be real bougie, you could say, as a matter of fact, these solutions are complex. They're complex solutions. You guys will learn about complex numbers eventually if you do pure maths. I love complex numbers. Everybody okay with the question?
Yes, sir.
Yes,
Would that
sir.
be complex numbers be like I and J and stuff like that?
Well, is I, but engineers, we typically use J, but in maths, you typically use I, but both of them mean the same thing.
Okay.
Yeah.
Because I remember seeing that in physics. I can't remember what topic we were doing, and we had I and J.
No. You're talking about vectors. Talking about vectors.
Yeah.
I talking about complex numbers. It just so
Oh,
happens,
that's
yeah. The purpose of
okay.
complex numbers, like this, all of this stuff, so cool. I will geek out. I love maths. Maths real cool. But like, I'll tell you fast, Virginia. You know how when you multiply something by a negative number, like on the Cartesian plane, is like rotate 90 degrees.
Yeah.
Like watch. If I have positive 1 here and I multiply it by negative 1, enter would go here.
Yeah.
So I rotate the number, how much degrees?
Is that one easy?
Right. You ever wonder what happens in the middle? Like, what is in between positive and negative?
Oh yeah. What is it? What is in between complex numbers or
Yeah. So you would say that this is the imaginary axis and this is the real
oh
axis. And so you have,
oh that's
so like, I could have a number here in the middle. It would have a magnitude and it would have an angle. So imaginary numbers allow you that extra level of is what we're looking for. That extra dimension you could say. Right? Because now you can represent numbers that, okay, so like you know how multiplying by minus 1 will rotate 180 degrees. Now you could actually represent intermediate ones.
oh I see. That's cool. Honestly, yeah.
Yeah, like watch.
I'd like to.
If I multiply 1 by negative 1, rotate 180 degrees, but like what happens in the middle? You know what I mean? So that's why
Yeah.
imaginary numbers exist. So now I could traverse anywhere between 1 and minus 1 anywhere. Yeah. And
That's
this is
actually
And this is called the Argand diagram. Yeah.
Okay.
Cool. So I called her a night. Did a lot of hard maths. Yeah. When next I see you guys, we'll finish this paper. Fun stuff. By the way, those that were there, I think you'll know how to answer this question. We had a really good session on this.
Of course, sir.
Of course.
And so remember this. This is just a recurrent decimal
Course.
and well,
Yeah.
if you want to find what it converges to, you can just find you sum to infinity. And well, yeah, we do a bunch of questions like this, so this should be fine. Yeah. Fun stuff, man. Fun stuff. So I'll see you
So
guys. Yeah,
tomorrow
Shelly.
for physics, we do revision too, or we doing?
I will do revision.
Okay.
Yeah. So bring out any question you want. I will do revision. I mean revision. I said revision. Polynomial long division get into my head. All right. Well, later, guys. Have a good night. Take care.
Bye,
Bye.
sir. You too.
Bye.